So, good morning, everyone. At least for me, it's morning. For most of you, it's morning. For some, already afternoon. Thank you for joining on this second day of the fundamentals training of MicroStream. So, I'm going to quickly do a recapitulation of what we covered yesterday, and that gives you also the opportunity, if you might have any questions, then of course you can ask that at that point, at that moment when I mentioned that topic that we covered, or of course, as you know, at any time during the day, if you come up with something, then you can also ask that at that moment, of course. So first of all, we looked at why we have developed MicroStream, why you should consider MicroStream for some cases. So we did that performance demo after Marcus did the intro, in general, what MicroStream is. And we saw there that Hibernate has some difficulties to, first of all, assemble the correct query that we need. That external data storage is slow due to the latency, that also mapping, of course, plays a role, and that you need to do quite some tuning with Hibernate, but in general, with any kind of tool that loads and fetch data from an external source. So that's the reason why MicroStream starts with the idea that your memory, your JVM memory, is the primary source. Of course, we have an external binary representation because you need to be able to keep your data when your Java process is not running. But the JVM memory is the primary source for your data, which means that queries can be done much faster. We saw there a factor of 200 with that query, where we were able to read those purchases of the bookstore. Did not go into detail about writes, but I have created also an example, which is also on GitHub, which I can link. It's also mentioned already during talks, etc. That also, for instance, writes are much faster. I try to store 2.8 million records, and that was much faster also with MicroStream. So then we investigated, we explored step by step from, let's say, from the beginning to the end, to how you can set up your project. First of all, you need to think about a data model, because there are slightly different concepts and things that you need to know around the object graph, working with an object graph and a relational data model. Relations is one of them, is the most important difference, because in an object graph, you have most of the time only references to one or several objects, and then you need to follow the references to others, where in a relational data model, you have all those tables in a database which you can access individually without going through the entire hierarchy of the tables, which is an advantage, but also a disadvantage if you need your information as a whole, as we have seen in that performance demo. If you need always to have the address, city and state and country, then you need to join a lot of tables all the time, which you get for free if you're using something in the data model, in the JVM as a data model. We also covered that you need to make sure that you can access then your data efficiently, so that you should have different views from your route. You should have, for instance, a list of all the cars, but also all the brands by default, although the brand is available in each car. That you need to split up that large list, that you should not put millions and millions of records in one list, but that you should split it up so that you can access it more efficiently, as maps are basically the indexes of databases. After we know what the data model could look like, and today we will cover how, if you need to migrate, if you need to change that data model, it's something that we cover today. So after we have the data model, then of course we need to do the configuration. As I said, probably the most difficult thing, in the sense that it's you need the most the statements that you need to write for the configuration are those the largest one in your project related to MicroStream. But as you have seen, that can be done also in 5 to 6 statements. But you need to do it properly, of course. As we mentioned, what the abstract file system is, so that you can write it to disk or database or any kind of other system like Kafka or cloud storage. At the end of the day, we will see some more examples around that. We have seen how you can define the directory. We also went into detail about channels, and that's an important factor in how channels work. So that's something that we have covered during that configuration section. And then we were able to link our routes from the object graph to the external storage, and that's the data in that external storage is loaded into memory when you start the storage manager. And then the last thing, of course, once we have the configuration done, we went over to the classical CRUD thing, create, read, update, and delete. Read is, as we mentioned at that point, pure Java. So we don't have anything specific in MicroStream, because Java is more than enough for that. We don't need that. We can use, for instance, the Java Streams API, but basically any kind of Java statements, method, whatever is suitable for accessing or filtering your data. Today, I'll look a bit more in detail about the Java Streams API, a few things if you're not that familiar with it. So that's maybe a refresher for some people. And maybe if I can tell you a few nice tricks also, if you're not familiar with it. And we went also into the details around the difference of the store method of the storage manager itself, and then the lazy and the eager storer, where it is important that you should not forget that commit statement, and because there you can send a group of changes as one block, as one transaction. But it's not really a transaction as in the database sense. But you can send a group of changes at the all or nothing principle to your external storage. So that was a quick overview of what we did yesterday, a small peek what we are going to do today. In a moment, I'll show you more in detail the agenda. Are there any questions around what we saw yesterday around MicroStream, questions that you have? Also, Marcus joined, so if you have questions for him, you can also ask them, of course. no questions, that is either super good or...
Good morning. I have one question. I know that some of the frameworks like Open Liberty works with hot reloads. So you're making changes in the code and the application is reloading instantly. How do you think, will it work with MicroStream? In that way, when it will not reload completely, but hot reload?
Well, if you look at those frameworks, but I'm not 100% sure about Open Liberty, but I know, for instance, but I think it is also Open Liberty is doing what they call a hot reload, but actually they do an undeploy and deploy your application again. So there is a difference between, am I redeploying my application or am I changing the class loader? So some tools, and you have tools like JRebel, which also do that for you, that they do a few magic tricks with the class loader. They change where where classes are loaded from. There are reloading classes, etc. And I guess if you're really doing class loader magic things, then you might have some issues. Some issues when you are changing a class that is related to MicroStream, which is in your root, which is in your object graph. But from what I know, that is that most of those frameworks just do a redeploy. Then, and that's of course no problem at all, because then it's basically the same what you would do by stopping your runtime and starting it over again.
Yeah. Okay. Thank you. And another question: can you tell us something about how to write lambdas with MicroStreams? Will the data survive? What is the best practices? So where to store the data? Yeah, in lambdas.
I come to streams, and lambdas is more or less related to streams. I come to that in a moment. But actually, you cannot store data in lambdas because lambdas are just a processing or just statements. But I come to, Marcus says, do you mean AWS lambdas as a serverless? Is that what, sorry, is that your question then?
Yeah, probably AWS, and maybe I'm not familiar with Google stuff.
Yeah, okay. So yeah, in general, yes, I can cover that this afternoon a bit, how we see that you can use the MicroStream in serverless environments.
Okay, cool. Thank you, Rudy.
I put it on my list so that I prepare it during lunch. As I said,
yeah.
As I said yesterday, there is some time this afternoon for topics that people bring here as interesting.
Thank you very much.
But yeah, short answer, like Marcus says, it is possible. There was a demo that Christian showed at JCon. The recording of that will be available in the next few weeks. But short answer, yes, it is possible, but I can go a bit more in detail, a few aspects that you need to be aware of, and a few best practices this afternoon.
Cool, thanks.
There was yesterday, unless there is someone other question.
Probably I have I had one
yeah, sure.
yesterday when trying to run and look through the Payara CRUD application, and I wanted just to debug and haven't managed to find the solution how I can debug it, for example, in IntelliJ IDE.
Yeah, okay. That's then something that I can show you. But yeah, that's specific Payara micro then. But there are several options. In short, you can use the plugin of Payara micro for IntelliJ, and then you can start your application in a normal way or in debug mode from within the IDE, or you can add the command line option for remote debug for your JVM, and then you can start a remote debug session from within IntelliJ. But I can, if we have time this afternoon, I can show it you, and otherwise I can send you a link where that is described.
Cool, cool. Thank you very much. Much appreciated.
So, yeah, yesterday there was, I think it was Oliver, correct? That said, well, I have an issue on JDK 17. Or...
Yeah, that's correct.
Yeah. Sometimes my memory is failing me. I know that there was a question, but not. So he created a project, and I tried it out, and let me switch a few, because there are so many pop-ups of Zoom that it's blocking my regular menus. I tried it out, and actually I found out that it is not JDK 17 that is a problem, but it is a problem between brackets that you are using a Java record. So if you remove that Java record, you use it here, then your application runs fine on JDK 17. So I had also the problem with Azul. So it was not the Microsoft JDK only that has an issue. So it works fine if you are not using a record, and if you are using a record, then you get that error that.
It's interesting. That's a good catch. So does it mean it mean it's not expected? Is this expected behavior or unexpected?
Well, I asked my colleagues, I asked the developers, is that expected or not? And they pointed me out that there is indeed in the documentation that can you handle records? Yes, you can, but you need to add that export, which is also in the stack trace. So
very well,
we know about that issue, and yeah, for the moment the solution is indeed that adding that exports so that you it can access that part of the JVM which is required to access records, because yeah, as you know, records are highly shielded off at the internals, so we only can do that through some unsafe through the unsafe class for the moment. So that's the reason why.
Good catch. Thank you.
So that's one thing. Then a question: who started creating that the result for that exercise? Anyone who want to share? Even if you did not create everything, just share your ideas, your thoughts, your progress, what you found difficult, what went well, etc., so that you can share your experience with the other persons, or that we can see if we need to improve that experience for users. So anyone who tried to create that car exercise and who is willing to tell something about it, and that also perfect fine, or did you all enjoy your...
briefly, but did get a JSON parse exception on the adding the name.
JSON parse exception?
I didn't really find out why exactly. I just had a few moments before the task. It didn't make sense because the JSON looked fine, but we got the parse exception there.
So I thought I was, yeah. So probably there is an issue with the JSON that you send to the endpoint and that it cannot parse it. Is that what you run into?
Yeah, but I couldn't find out what's wrong because the JSON looks fine.
When you create your objects, did you include a, or by default, did you include the default no argument constructor?
No.
So
okay.
if that's one of the tricks that you, well, that's JSON. So if you have a constructor like this, then JSON, then most runtimes are unable to create based from a JSON for a brand is unable to create a JSON POJO because it needs a no argument constructor. So if you have something like this, then you explicitly need to add the no argument constructor. That's something about JSON, or yeah, depending on the framework. You can also put some JSON annotations here, so that it's not like this. It is JSON creator, so that it knows that it should use this constructor and that you need to define JSON properties so that you need to specify explicitly the mapping, because then it cannot figure it out itself. So that might be a solution for what you encounter. Anyone else who tried? As I said, it's fine if you did not do it. You can do it at any time. You can look at this solution, of course, also to see to learn about it. So what I created as a result. Anyone else who tried for it?
Probably I understood that it would be done after the second day, so maybe I was mistaken. Sorry.
Yeah, no.
I played with the example. I'm not a Java or Maven guy, so I fight it with the project itself a little bit. But I went through the code and I saw how the requests are handled. So that's a nice example. So thank you for that.
Yeah, I will cover some important aspects in a moment also, so that yeah, it's a few things, a few tricks how you can do things are included in that example. So I think it's useful that I share it with everyone. So I will do that. But I was just wondering, as I said, how was the experience? If there was any issue that we need to address, like make things easier or clearer or whatever. So it's okay, it's fine. Yeah, so one of the questions was create an external, create the configuration externally, as most people do. I'm not saying that everyone is doing it or that you should do it, but at least then with that file here, then you keep sensitive data, although there is no password here, but in general, application configuration values should be placed in some files or defined externally, not within your code. That's a practice that a lot of people follow, and it's also the 12-factor application principle contains also an item for that. I'm not going to change the number of channels, so that's why I just defined here the tutorial directory, and I've put here again in the link where you can find all properties. So if you want to change them, I'm just storing the data here in a certain directory, MicroStream data. And then I can, as we have seen yesterday, I just load that one, create the foundation, set a root on that, create a storage manager, start it, and then do some initial data, because that's one of the things that I cover also this afternoon about some best practices, some hints that you can do, is that you probably not like this, but that you should have always easy mock data available so that you can work easily during development. So I'm just setting the company name. So my model is that I have a company with a company name, and I have a list of brands and cars. So here I'm setting at the name, I'm defining a few brands. I also add one car. And then here is an example of that eager storer that I use. So make sure that the entire object graph is stored unconditionally based on that eager storer. So I know this is not a penalty, a performance penalty, because yeah, it's only if it's empty, then yeah, it's only these 5, 6 objects that are stored. So that's then an easy way to make sure that everything is stored, and I don't need to think much about what I need to store. And it is also an example of how you can use it, that storer, lazy or eager storer in this case. Yeah, for the rest, it was from the template. So that's not that special. Cars, you should always, just as you have in a relational case, in a database case, you should always be able to identify a certain object uniquely. For a brand, that's probably, you can use the name of the brand. That should be unique, I guess. There is no, it does not make sense to have 2 different brands with the same name, because that's weird. For cars, probably, yeah, there are unique identifiers. The unique number, which is there, so somewhere on your car, that the W or whatever, there is a long number engraved in your car somewhere, but that's probably not easy. So you can also use what's called in the database world a technical identification, just a sequence, just a number that increases one by one. And for that reason, I'm using here, of course, I have only one, but I can add other identifications if my model is larger. I can have a kind of sequence by using a atomic long. That's already taking into account that you probably are using your application in a concurrent way, that you have multiple users accessing the same endpoints, etc. So you need to make sure that your concurrent access is fine, and that's part of the advanced training, but this atomic long takes already care of it, so that we are sure that this is safe, that we cannot have duplicate ID numbers. And to initialize that one, I'm using again Java 8 stream to find out which is the current maximum number, because if you start up your process, you can have a look of in your data which are already there. Again, if you are having already millions of cars, then this is not probably the best way, and that you should store it already as a value here within your root, for example. But here I'm using an example of the Streams API, how you can get the IDs, so map for all the cars, map it to a long, find the max number, and if it does not exist, then I start with -1, because by default I do +1, so I start with 0. But there is always one in this case, because there was here in the initialization, sorry, there I started with already with 0, so it finds, then if I access this one, he accesses then the list here and starts with the next one, which will be number 1. Yeah, here there is nothing specific, just a few lists. This is something that you need to decide if you want to return, for instance, the list of brands here immediately, or that you copy the list in a new array list, because if you return your list of brands, for example, but also the cars, just like it was in my example, that means that you can change it outside of your root. So you can add one, you can have some code or somewhere, a statement that just adds or deletes something, which is no problem at all, as long as you don't forget to store it also. You remember, if you make changes and you don't store it to the external storage, you have lost that change the next time you start your process again. So some people also, for reason of immutability, this company object is not immutable because I expose here the list of brands, so I can make from externally a change that impacts the internal state of that that object. So you might decide to, as I showed here, return a new array list, but that also means that you need to be able to store changes, so that you need to access the storage manager from within the company. So then you probably don't have set brands, but you have a method like something like public void add brand. And then where you can add on the brands the one that you have added, but then and then you can make sure that, for instance, with your storage manager, but then you need to inject it. That's one thing, which is handled by those integrations, as I said, which we have for many frameworks, but that you should also do a store here of the entire list. So that's then a trade-off, I would say, that you need to have some MicroStream specific classes within your domain model, which is good and not good. That's depending on how you think about those, what your company rules around that. Every company has a bit its own rules about what is considered what they should do in a project. Yeah, here there is nothing really super special going on. It gives you only some examples of that rule store what is changed. So as I said, we change the list here of brands, and the brands variable, so you need to store it, that one. If you do an update, then we update the brand instance, so we need to store the brand instance. So that's, as I said, that can be a trick to know what needs to be stored. Same for the cars. There are a few examples for the Streams API. Again, quite simple. Most of the time in real projects, of course, you don't put the logic within the controls itself. So you just delegate the functionality of checking of does the brand already exist, etc., to some services or repositories or what the name might be in your specific framework, and handle it there. And then this is just those endpoints here are just a gateway to receiving and sending responses out.
I have a question regarding collections.
Yes.
You told us that MicroStreams is aware of immutable or mutable references, and that it prefers immutable references, obviously, because it doesn't have to check them for changes, right?
Yes.
Does that also include internally immutable data structures, like immutable collections?
Yes, and for those immutable collections, as that's what the JDK17 binary handlers that I shared yesterday as an example. Oh, yeah. There we need to have some specific handlers for it because they are immutable, they need some special treatment. But yeah, it goes also for that. So
do we have to use special interfaces for those, or
no? We just have a handler which takes care of handling that type of Java object. Okay, I don't think that you are intending to use immutable object here as a brand, for instance, because that means that you need to recreate your entire object again when you add a brand, which means that that MicroStream has more work, because a new immutable object means that he stores everything again, because he sees it as a new thing. But if you have the case that somewhere have an immutable object, like records are also immutable, so it is possible to use it, but we have specific internally specific functionality around it. Did I think I closed it? Can I quickly go back with it? Because I added the binary JDK17 one. So see, we have a specific yeah, we have a very nice long name about it. So we have a specific handler that can handle that immutable collection, which is added in Java 15 or something. There is some specific immutable collection. So we can handle that internally. So we still have the rule that back to my exercise, that you as a developer should not add any kind of interface here to a class, not add any kind of annotation, so that you just use Java as is. We will make sure that if there is some special requirement because of the type, like immutable, like records, that we handle that by our code, but the developer should not be aware of that. He just used Java as he has learned it at day one when in the Java education track, so pure Java. Does that answer your question about immutable and special instances and objects?
Yes, I think so. That it means that MicroStreams will always use reference equality to check my objects.
Yep.
Can I change it to value equality, for example?
There is, I think, because as I said, everything is an interface. I know there is a lazy fields evaluator which defines, and there is, so yes, there I think there is, but actually that will hurt the performance, because you will always execute the equals method, which is more expensive than the checking if two references are the same. Or am I missing something?
That could be the case, but it would open up more possible data structures, right? For example, in Clojure, another JVM language, there are immutable data collections that copy by default, but they're very efficient internally. But the reference is always new. So for example, these kinds of advanced functional data structures, I would say, would be possible when MicroStreams is checking value equality, but not possible when it's checking reference equality, because as you said, then the performance will be really, really bad.
Yeah, we have something copy on write array list here also in Java, pure Java, which is also an array list which is immutable and makes a copy every time you add or delete something on it.
Exactly, this is a good example.
Yeah, I have to look into it, but probably the answer is yes, it is possible because everything is an interface, but I don't know by heart how to set that configuration for the moment, so I have to look it up myself. I'm not sure that, because yeah, that exercise is just on some basic things, just to get things in your hands that you start thinking about the MicroStream way. As I said, there is a few things differently, not that much because you're using pure Java, but about how to use your data model here, about what to store, etc. So this was just a example on that, a small example to get you started. Any other question, or do we continue with our agenda?
Yeah, I have one question. Huh?
Yeah.
So let's say I'm updating multiple cars, and when I'm updating like fifth, I throw exception. And let's say I'm using lazy storage. So do I get it right that basically like it won't get persisted, but the data in memory will get updated. So my application will see updated, and when it restarts, it will see like all the data.
Yep.
Yeah. Okay. Thank you.
That's correct. If you're saying I was updating a lazy reference, there you can work around that problem of a rollback, because that's basically what you're mentioning is a rollback. You can do it quite easily. That's for something in an hour or something, but yeah, because you asked the question now, you can do lazy clear. So that means that you drop the value from memory for that lazy reference. So
No,
since you,
sorry, but in this case, the actual objects will still be changed. I think
correct. It is changed, but since it was a lazy, you can drop the lazy. But that's, as I said, lazy is for in an hour. So if you did not store the lazy and you do a lazy clear, then you have lost your changes. And if you access that lazy again, then it's loaded from the external storage again. So if you're using lazy references, then you can easily get a rollback. If you don't use lazy, then you need to have its helper method, which takes like 5 or 7 statements to reload actually the data from your storage, and that's part of the advanced course.
We got it. Thank you.
But the remark that yeah, it is updated in memory, it's a good one. Be aware of that, that if you change something in memory, that is something that you have performed, that you have done, that it is there, it has changed your database, if in that sense, the MicroStream database, because that's your pure JVM objects. So yeah, be aware of that and do a strategy around it, and strategies around exception handling, rollbacks, etc. is part, as I mentioned, of that advanced course. I will reference to that later at the end. The next one is October 13 in 2 weeks, so you can still subscribe for that one also. Any other question? Which I'm totally fine with question. Don't get me wrong, but it's the best way to learn the things that you find important for your use case. So what I have added a few things on the agenda. I forgot to update it, but in general, we are going to, we already did review the exercise. We reviewed yesterday, going a bit deeper on Java streams in a moment, but I also add something which is the transient, the Java transient keyword, because that's something that we take into consideration. Then we go also to the lazy loading, how you can handle what it is, how you can use it, and when you should use it. The legacy type mapping, which is basically the MicroStream functionality to be able to migrate your data model. So you are in production with version 1 of your app application, then you need another property, you need a changed structure of your data for whatever reason, and then that legacy type mapping handles things for you. We see the basic things of legacy type mapping, the automatic one in this course. In the advanced one, there is the advanced usage and advanced way of migrating your data model. We have a few slides around backup strategy and example, and a few things around best practices. I have already put an additional item around integrations, because there was also yesterday a question about, I briefly covered it yesterday, but a bit more in detail about integrations we have with Spring Boot, Quarkus, etc., Micronaut, etc. And then I can quickly show you how you, for instance, can use Azure storage, Postgres database, etc., or again, any other question you might have at the end. So I repeated also, it's during the exercise, we don't require any interface, any annotation, so we don't need that. We just take all the data, all the properties, and they are stored. There is one exception which we take into account by default, and that's when a property is marked as transient. So transient properties are not stored to the external storage. That's default behavior. But you can again write a custom behavior and you implement the persistence field evaluator, which, for instance, you can say every property that starts with an underscore. Sometimes people use the convention that properties with an underscore are a bit internally, that for whatever reason, it helps you in organizing your data, your code, whatever. So if you write a persistence field evaluator that says that every property that the name that starts with an underscore, that it should not be persisted, then you can do that. And then you don't need to provide a transient word, of course. I have created this a really small example yesterday for the transient. So if something is transient, I put the name ignored, then actually it will not be stored. So let me remove the data which I had from yesterday. So what I'm doing is just I'm creating an object with the 3 properties filled in, the code, the name, and ignored, and I can print it out. So that's in my test application. So I print out all the products. So initially it is there in the memory because I create a new product where I set that ignored value. So it has a value, it is there. But when I run it again, it's loading it from external system, my instance. So then it will be NOLL because it was not stored. That means I have lost the value in the conversion to and from the binary format. Where can that be handy? As I mentioned, sometimes if you really encapsulate your collections to your object itself, like I said there, instead of returning a list of brands, you return a new array list of brands, so that the changes that you make outside are not does not reflect, does not impact your object itself. Then one thing that you can use that transient word for is, of course, if you are using this storage manager here, because it has no sense of storing the storage manager, the content of the storage manager, and that is more than a few references. That's a few hundreds, a few thousands. I'm not sure exactly about the number, but it's quite a lot. So it has no sense at all to store that storage manager to external storage and read it again next time. So that transient word is there, especially helpful if you are doing that so that you can store your collection, changes to your collection from inside the object, or, as I said, if you need a helper property to organize your code, which is derived from other values, or is it's a derived value in general, then you can also use that transient keyword. There is a question, could you maybe do an example on transferring data from an SQL database to MicroStream like a parser? So you mean an example of how you do a migration? Is that then the question, that you have currently a database and then, yeah, okay. I'm not sure. I don't have that available for the moment, so I'll see what I can come up with if we have time for that this afternoon. As I said, there is the field evaluator. persistence field evaluator, where you define if a field in a certain class needs to be handled, yes or no. So it is, you can just return true and false, and define based on that value, based on the information that you get from the field. As I said, a field that starts with an underscore is not important, so you can return false. And again, this persistent field evaluator can be defined by using that foundation. By that configuration foundation, there is a method to define a persistent field evaluator, so you can use it like that. Small thing, most of the things that I covered today are smaller things. Yesterday we had a nice story with a beginning and an end. We started in the morning and ended in the evening. It was a nice story. Today it is more or less little things as added as an add-on to what I told you yesterday. Question about this transient data, this persistent field evaluator, or is all fine? Yeah, all seems fine because it's not that complex, I guess. Java 8 streams. We call it the MicroStream query language, because we always get the question, what query, how do you query? And then, yeah, it is, as we already mentioned, and that's the reason why I mentioned it so many times, it is pure Java that you are using for queries. And the Java streams, it's already quite some years now, so hopefully you all had the chance to play with it, to use it in production, because yeah, you can do some nice things with it. It's in the most cases, it makes your code more readable in the sense that it clearly shows what it is doing. In some cases, people overdo it, and then it becomes a nightmare to find out what it is doing. So yeah, find also a balance in that. But yeah, streams are nice in that sense. You can create a pipeline of actions that you need to do on a collection. So, as I said, it is a pipeline of actions. It is a series of processing steps. Sometimes I get, if I see on internet, there is sometimes the idea that streams are a data structure, but that's not correct. You probably know that. So it starts from a data collection, a list, arrays, whatever. And then it processes that according to some rules that you need. So you need to do some intermediate operations. They are called intermediate operations, like filtering, mapping, sorting, those kind of things. And then at the end, there is a terminal, only one terminal operation. And that terminal operation then puts that entire series of processing steps in action, and you have the result. That also means that if you're defining a stream, that only when the JVM encounters that terminal operation, then the action starts. So let's say that you have a method with 100 statements, and you start in the beginning with, for instance, you all know it, list.stream, and you have a filter, and in between somewhere on line 50, but only on line 100, on statement 100, you have there, for instance, the collector to list. Only at that moment, your entire stream gets into action and is performed. So that's also good to know when your operations are performed, and that's when you have when the JVM encounters that terminal operation. As I said, there are intermediate steps. The most important ones are filter, map, and sort. They handle your stream items. They can convert it with a map, etc. And then the terminal operations are consume, and so consume each item of the stream and do something with it. For instance, consuming can be printing out to the console. That's the way that most people use it in examples for the consume. But of course, you can do some more meaningful things in real world projects. Collecting is then creating a list, set, map, array out of the results. Or you have the reduce and aggregate, which comes from the principle, because streams are not entirely, but also a bit designed to that map reduce function, which you have in many languages, where you can do an aggregation, for instance, creating a sum of some elements in your stream. Nice thing is that by just adding the parallel method from a stream, you enable parallel processing of the entire stream, which is nice that you can switch from serial to parallel that easily without changing anything other. But if you ask me, parallel is only really beneficial in a few cases, and it's beneficial in only more efficient in a few rare cases. Don't start doing parallel for all your streams. Make sure that you are testing it out to see if parallel really helps speeding up your processing, because most of the time it is not. Unless in those specific cases, but yeah, always try it out, because parallel is in some cases even worse. I also mentioned yesterday with that find first and find any. If you do a find first on a parallel one, then that's a nightmare. So I think I never used parallel in production at all, because most of the time I'm creating those administrative applications where you handle those cars and brands, and you have maybe a few hundred, a few thousand things in your stream. But yeah, that does not mean that I need to use parallel for those kind of examples. The serial is faster in those cases. So the query language for MicroStream. A few examples. We already saw a few things. I'm going to first start with this one. You can create streams in various different ways. So you can, for instance, say streams of. Am I correct? Yeah, I'm correct, but I have now an issue that this class is also called streams. How did I do it? Okay, so how can I create a list of integer values? So yeah, I can just, for whatever reason, if I need a fixed range of values, I can do a system print online. For me, writing lambdas is sometimes a bit difficult in the sense that I'm not 100% sure how to write it. So I always rely on the IDE, which says then this is the way how you write a lambda for that stream case. If you have a consecutive, if you need a consecutive range from 1 to 10, then you can do it like this. And some people say that they are using it as an alternative for a for loop. I was so used to writing for loops that I'm not using this as a way of, as a replacement for loops, but it is, of course, possible. And if you run it, no surprise, you have then just printed out each list there. This one is the first one, the 6 is the last one, and then the 1 to 10 to 9, because it was exclusive, the end one. If you want to including the 10, then you need to take a range closed. More interesting is how that you can create a stream out of an array. Sometimes you don't have a list, you don't have a collection, a set, map, whatever, but you have a array integer of this, but it can be an array of anything. And then there is this little method that you need to know, that you can convert this array to a stream. And then, of course, you can start doing whatever you like, filter map. So all those things are possible. That is the easiest way of getting from a array to a stream. Some people, I saw it, are using first to a list, because everyone knows the way of creating an array to a list, but it is easier to create it immediately, a stream out of your array. As I said, consume. Consume is do something with each element of the stream. So I have here a list of books. I can get a stream out of it, and I can here see the for each is the consumer. So yeah, I can consume a book, and I can do a system out print line of the book name. Again, this does not make sense because you can do a for each immediately on the list itself. That's why you have that that warning here from IntelliJ, but probably you are doing some kind of operation on the stream, and at the end you do a for each. You don't need to do this, of course. You can I can call any kind of other send to whatever, send to external system, wherever you need that that book info. You can, of course, then use it like this, that you for each of the streams, after you have done a filter, whatever, which makes more sense, which is more realistic. I can execute that, not that it is it was the consume stream, this one with the books. And again, I'm reading it from here, a JSON, to have some real data so that you can play around with it. What's not known by a lot of people is that you can also convert your list, your stream, then to an array. most people, they all know that you can do stream collector to collector to list. Again, do some meaningful and do a filter first, but you can also collect it to an, not like this, to an array, and that's I think that's the reason why people do not know it, but you have a, and I know that it's possible, but let me peek to the result. There is a to array. That's the one that I need. So the to array is a special collector that converts your stream results to an array again. And you need to say how it is initialized. So that's why you have this lambda here saying that I create a new instance of an empty array of books. And then he knows the type, and that needs to match, of course, the stream items. Yeah, there are the list and the set here. I guess I'm not going to show that because it's so obvious, everyone is using that. This one is also a nice one. You can concatenate strings. You have here the collectors joining, and you can say, I'm joining it with a comma space delimiter between all the elements. So that's a nice one for joining strings through a stream. Yeah, because I have some things here which I did not finish properly, so you will not start. See, that's a nice way of creating a, for instance, you can create using that collector here, you can easily create a CSV file. That's one of the ways that you can use streams for, is to creating CSV files very quickly, very compact, very nicely. Discussion yesterday, find any, find first. So be aware that there is a difference. So I have my general rule is that I always use find any, because I use find any to find a unique element in a list. So find any is faster in that case, in most cases, than find first. There is also the possibility, we said that we have collectors, we have consumers, that's what we covered. There is also then the reduce, that you aggregate, that you do a reduction of the data, so that you combine elements from the stream, and that's the aggregator, that's the reduce ID of streams. So if we want to explicitly make use of that reduce, you can do do that. For instance, but again, I'm not very familiar with the reduce most of the time. Let me try, and otherwise I peek again. Not filter. I need the prices. So I need the price, and then the identity. So what is the value that you start with? That's 0. That's the first one. And then you need an accumulator. So you need to add the current value of the stream item to the value that you are keeping as a result of your reduce, which initialize to 0, and that's then the big decimal add. So that's how the reduce works. And then that means that you have created the sum of all the book prices like this. Let's see if I did not make a mistake, because I'm most of the time doing it differently. Because reduce is the generic way, so that's, I assume that's correct. We should check it, of course. But what I find it more easily is that you indeed start here with a map, but that you don't map to a generic object, which is of course here a long, but you do a map to a long not, because to a double here in this case, because you have values that's, and you cannot do it in one go. Okay, so then we do it in 2 steps. Because it is a big decimal, it is the double. Where is the double value? Like this. No. Let's see what it is. But the point is, if you have a long, so if you have primitives, long integer, whatever, you can just do the sum, which is in my ID easier than that reduce here, but price is a big decimal, so big decimal to yeah, I'm saying not too long, and then of course it's no longer a big decimal, but it is a double. So let's cheat a bit, and now we're returning a double. That should be done in one go, no? Okay, I thought it was possible in one go. Then you have to do 2 steps. Most of the time, we prefer this way, sum instead of this reduce, because, yeah, but that's just a preference, I guess. Instead of sum, you can also do, you can do other things, and you can do count, average, distinct values. So you can indeed do several kinds of operations on based on those numbers as statistical things like a sum, count, averages, and those kind of things. There is also in SQL you have the groups by. So I want to know. Yeah, here it is the price, but maybe let's change this because that makes maybe more sense. How many books do we have for each author? So author X has 2 books, author Y has 5 books, etc. So at the classic groups by, how can books group author count, for example? How can we do that with streams? That's also something that you can do. This so stream, and then you need to do a group, a collect, and I'm not using it every day. That's why I have sometimes. I know that it's possible, but I don't use it often enough. So then you have a special collector, which is the grouping by. So I group by author. So that is the key value. It says the classifier, so that's the one that ends up in the key here. And then we start reducing again. So we start with count 0. We add 1, and that's then becoming weird. You have 2 values, and what do you do with those 2 values? You add them up. If I did not make any mistake, then no, I don't. I need to do a return. Because I need a identity, a mapper, and then an operator. Probably because I'm using primitives that he cannot handle it. Okay, this is normally something how you can do it. The group by, as I said, I'm not using it every day, and that's why I'm able to write it. That's also a very useful thing, of course, what you have in queries with SQL, but you can do it also with the Streams API. For those who want to play with it, you can do the same for books, but we did most of them already. Maybe covering a few of them. How do you sort? So you can you have here the sorted, so you can order them, the order by, and you have here. Then you can here say what should be on which field or multiple fields should things be sorted, ordered. And then we have, as the question was, we should do it on name. So that's the way how we can sort the entire thing. Sorting descending, then you can say here that you need to have the reversed order, and then it goes from Z to A, or the inverse comparison, of course. You can do it, of course, on strings. You can do it on values. You can use your own comparator. You can put, instead of here using comparing, that's if you're working on a item that you're sorting on an item itself, but you can use a comparator in general. Then you can specify here a comparator. You see, I just need a comparator which handles a book. Some people also use those lambdas as a separate statement. So let's again start with get every book that's where the name starts with an A. So then you have here books, stream, filter, and then you have that the book is get name starts with an A. That's how most people do it, but you don't need to write it here in line, because this is what's called a predicate, and a predicate is an interface. So you can say, or let me do it like this, and then is not refactoring it like I was thinking it would do it. So let's do it then the long way. I have a predicate on a book, which is start with A, and I write it like this. And then I can just put it like this one. So this allows you to create some generic filtering where you pass in the predicate as a parameter on your method. So you can have one generic method that filters on books, and one time you filter it on the name, the other time on the author. The next time you filter it on the genre, horror or science fiction, whatever. But you only write your query once, your logic once, and you can add here just say a filter. And you can even make complex things. For instance, you can say book. I'm going to create also a predicate on male authors. I think that's also here in this example. Get author, get gender equals. I think it's written out completely. It does not really matter. How can I combine this? So then we have a predicate on a book. So filtering starts with an A, and it must also be a male author for instance. So that, as I said, makes it possible to have only one method which perform a query with a certain filtering and make the filtering dynamic. So that's a very nice option that you have. If you have questions about these things, because now I'm going to probably a few more advanced things, which maybe not everyone is familiar with. So then please interrupt me if you want more info around these kind of usages. We have books, and we would like to have a collection, which might be a list or set, so that's not specified, of the unique authors. So unique means probably I should use a set, but I can also use a list with streams. I will show you in a moment. Again, that depends on what you like. You probably know it. So converting it from one type to another type in a stream is with map. So I can say map in this step the book to the author one. And this is one option. So I can make sure that at this step there is some unique check, and streams will make sure then that in this list each author is unique based on the, and probably I don't have it, the equals and hash code. So be aware that it's using just the proper equals and hash code. So that's something that should be added here then if you're using distinct. Another option is, of course, that you rely on the functionality of a set, which also makes it unique, and that you just collect to the set. I have no idea which one is the most performant, because both do the same. My instinct says that this one is a bit faster, because here you need to keep intermediate values because it is processing an entire stream, and it can do other things that, again, if you need to have other filtering, for instance, on all the authors, then this is probably better than first collecting into a set and then stream it again and perform the filtering on the author. So it depends. So that's the reason why I mention it. if it's purely collecting it, then probably the set here is more efficient than the list. I have to show you now the model because each author has a list of addresses, so or might have a list. So each author can be located on one or more addresses. So if we are requesting a set again, probably of all the unique addresses of our authors, how can we do that with the stream? And that's with a flat map, which is confusing for me always. But a flat map always takes a stream. So instead of just converting it from one item in your stream, like a book here, and convert it to an author item for the rest of the stream, a flat map works on streams as an item in your stream. So we have a book here. We have here the author, and we have his list of addresses. But that is a list, that is not a stream. So we need to make a stream of it. And what flat map then does is that it takes all the elements of all the streams it encounters and pass it on as a next item. So here, and you can see that if you do it with filtering, you see here the stream expects an address, just a simple a single item. So we have done with flat map, you're always doing two things. Because it says map, so we convert it. It's not necessary, but most of the time you do it. The example that they give if you don't do a mapping is that you have a stream where each item is a list of integer, and you just pass it on as just a stream of items. So instead of a stream of list of items, of ints, sorry. But most of the time you do a map. In this case, we start from a book and we convert it to an address, but we also do a flattening. So we have some kind of collection, but actually you always need a stream. So you have some kind of stream, a group of data, and you flatten them out. I have a image for, I found an image for that, which, yeah, there are here examples for those who follow the slides. So you have here always, you have your item in your pipeline, in your stream is a collection stream. Actually, you need to have it, but you can convert it with the stream method as we have done in the example. You have here a set, you have another set, you can have as many sets as you like, many sets collection, and then that's not shown here, you can convert it with a map, convert it to another tab, but you also spread it out to individual items in the pipeline. So I'm not going to use filter here, but just collectors to set to make it a unique one. So flat map is useful as a query element. So if you go from one item and you have then here you go to a list of items and you want to handle them individually, then you need flat map. Questions about this? I have one or two more, but These are the most important ones which you should use or can use as a query language. Since JDK 16, so for those who can work with JDK, can use JDK 17 already in their project, there is something new, which is called map multi, which is a combination of filter map and flat map. So it's everything together. So it is a very flexible one. So that map multi, you can look it up with some examples. So this is the Java doc one. So it accepts a stream. So it on a stream, it accepts items of type T. So for instance, a book. But that consumer that you specify here, it pushes items of something else of type R. R and type T can be the same, but can be different. So we can push something like a address further along. So that's the map one. But in that consumer, you can do, you can conditionally call this consumer. So you can say, oh, if my country is located in Europe, then I don't want to have those items in my list. So that's the filtering aspect of map multi, because this consumer, yeah, you can write X amount of statements. It's not a single statement that you can do, so you can write multiple. But it has also something from flat map in the sense that you can, for one item in your stream, you can push multiple items further down the stream or to your consumer. So you can create from one item, you can create multiple. The silly example that I've not put it here that I usually make here is that if you have a stream of numbers, of integers, 1, 2, 3, 4, if you have, for instance, encountered 3 as an item in the stream, then you push 1, 2, 3 down to the stream again. So you create 3 additional items. JDK 16 plus only, of course. So if you're on 8 or 11, you cannot use it. There is a question about, is it necessary to know the streams API like bidirectional? You mean bidirectional collections like a list? You have their linked list, I guess it's called, which is bidirectional. But stream always operates in one way. So if you're feeding a bidirectional collection, then it's going only to use it in one way from like a regular list through an iterator. Not sure if that is your question exactly. Okay. And now that I'm thinking about, if you are doing filtering on a linked list, you should not. Yeah, I'm not sure how it works then, because you can filter out the element it was linked to. So in going backwards, so that's something that I should look into more detail what then happens. That was streams. I hope most of it was familiar to you, maybe a few nice things. For all the examples, there is also always a result here. You can I've also created some exercises where you can play around it, but I always have put here the results so that you can check if your solution is the same. But sometimes there is more than one solution, as I said. For instance, with that distinct here, there are more options. at least it was interesting for one person, so that's already a good thing. I propose that we have a break here now for 10 minutes, so at clock at 55. Then we can start with the next thing on the list. So hope that everyone has have a good short break. Coffee, tea, whatever is drinking, water is filled again, and that we can continue with the next important topic. That I think is we have two important topics to go. I guess before lunch we do the lazy loading, and after lunch we go over that legacy type mapping at the way to evolve your data model. First, are there any questions regarding what we have seen for the moment? Then let's get started with lazy loading. Yeah, why we need it, that's probably the most easiest question that we will cover. And what are typical usages for lazy loading. And then you will see an example of how you can use the lazy references and a few mechanics behind it, how it works, how it is implemented, so that you know how it can help in reducing the amount of memory that you need for your application, especially when you're having large objects like images, documents, binary documents or whatever, or that you have historical data, as mentioned yesterday, data which you do not access often, but sometimes you need it, and then there you can make use of that lazy references. How you can release it, there are different strategies, an automatic one, a manual one, so we cover them. There is also a link to our documentation, so that gives you some information, and here, and there are other, you see there are 3 pages which describe the lazy loading a bit more in detail. We will cover it here also, of course. So yeah, as you know, we put everything in memory, but yeah, sometimes the data cannot fit into memory or is not needed all the time with those historical data. So then that can be solved then through that lazy operation. So we have a lazy class in MicroStream, which acts as a placeholder for some data which is already in object graph, because you have that lazy, but the actual, it's kind of a proxy. The data still is located in the storage, so it's not loaded by default. Yeah, that's what I said. So historical, not all the time. Binary data, it's a lot of data, so it is good that you can access it for your request, but then afterwards you should remove it from memory again. But actually, if you would remove it, if, for instance, say you make it NOLL, byte array for images, give an example with images. So if you have a byte array with images, and you would remove them by setting that byte array to NOLL, then actually you could have deleted it from the database. So that's why we have that lazy, so that you can clear it, but it's not deleted actually from your database, only removed from memory. So as you know, if you have there's an example here of 100 million objects in your storage in this kind of object graph. If MicroStream starts up, then you have those 100 million objects in the JVM memory, which is fine if they are not 5 megabyte images, each of them. Then you of course have a problem. With lazy references, that is the different. You will see we have that lazy object, but if MicroStream encounters that in the storage at startup, it does not load it. It loads a object, and yesterday I mentioned already, it creates an instance, requires around 1,000 bytes to so including metadata, etc. And there is a last usage timestamp, more on that in a moment. So instead of loading the entire object, means that you just have there an instance of that lazy, and the data stays on disk. Also mentioning that 1,000 bytes, so do not make a lot of small lazy objects. Don't make each long object, for instance, as a lazy instance, because then your long object is only, I think, 64 bits. And by making it a lazy long, then you are creating 1,000 bytes. So make larger groups, or like I said already, those documents, binary data, historical data, as we saw in the purchase demo, with the purchase in the performance demo, that you have the entire purchases of a year of a shop. If you make them lazy, then that's a large block where it is more efficient to only have that proxy there in memory and not the entire data. As best practice, we say that you should always use it on binary data, in the sense that if you have documents, images, blobs, whatever, with whatever content, then you should use it. There are, of course, 2 options possible, just as you do with databases, where their best practice is that they say that you should not store those things within the database, but only a reference to outside, to your document, to your image, for example. You can do this. You can do the same, of course, here also with MicroStream. You can just keep that reference to where the actual document is, and then the document itself is never part of the database, so it never consumes the amount of memory. If you need to access, then okay, you have the reference and you can load it, and that's also, of course, a way of working. As with databases, a lot of people also put those things within the database, because then you have one single storage, one single place where everything is located, the data and your files, images, documents, whatever, in one place, which makes it easier to handle because of backup, for instance, etc. So you can do the same with MicroStream, but then use that lazy, so that it's not loaded all the time immediately into the memory. Other best practice that we say is that you should always use it on a huge collection, especially with less frequent data like logs, outdated data, historical data, those purchase information of previous years, etc., etc. So that makes it also a good candidate to make use of that lazy reference. Also mentioned yesterday, if you have huge amount, a list with a huge amount, millions or billions of records, whatever. Don't put it in one single collection. Put it in separate things. Put it in a map, for instance, so that you can index it. And then there it is also, especially when it is large, that you have the option of putting it as a lazy value in that map, so that of course you need to swap then, of course, all the time if you are accessing all the different bits and pieces, but at least then you can access, or you can handle millions and billions of records with only, let's say, 4 gigabyte of RAM. Processing time, performance will of course not be optimal because you're always swapping in and out things, but at least you can handle it, which is otherwise maybe not possible. Yeah, there is, whenever performance is that important, you can always put data there, of course. I would preferably change that last sentence, for instance, because there was also that question this morning around serverless. Probably if you are doing serverless implementations, you implement more things lazily, and you define more things with that lazy option, because then when your Lambda starts for the first time, then it does not need to load everything, so that it is faster, and you only load the data that you need for that specific request. As you maybe remember from the performance demo from yesterday, on my machine here, it was an example, but loading for that query, even those 200,000 records for the performance, for that purchase information, was also done in 70 milliseconds. So you can load a reasonable amount of data rather fast with MicroStream. So that lazy option is definitely something that you have to look into for also if you're doing serverless. Let's yeah, how do you work with lazy? So lazy is an object. Maybe I can just show the example that that will be easier. So I have two different solutions. So I have a model. So I have a photo album. I have photos with an ID and description, and I have the byte array, which defines then, of course, the image. This is here JSON-B tetrangent because I'm loading them. I was loading them? No. Yeah, I'm putting here it as tetrangents because when I return all the photos, I don't want the photo itself in the binary output, because if I'm doing a rest endpoint just here on the command line or in the browser, you cannot actually see it. So that's the reason why it is here. But yeah, I have photos, small data, a large block of data. They are ranging from a few hundred kilobytes, I think 300 or 400 kilobytes, to one of the images is 2 megabytes. So I try to find some higher resolution one, so you can look at. So it are pictures that I found somewhere. So it's not even my pictures. So that's the first option. We have here a photo which is part of our root, which contains a list of photos, which means that when we start the storage manager, that it is loaded into memory, and that you have that data set, those bytes available. The other option is that we have a lazy photo. A lazy photo where we not just specifying byte array, but we specify as an instance of a lazy. Lazy is an interface of MicroStream, which has a few interesting methods. Get, as it says, return the referenced object. If it's not available in memory yet, then it loads it in memory. So it loads it from the external storage. If you just want to see if it's there or not, if it's available, then you use it. If not, then yeah, maybe it's not that important. Then you give the option to the user to click on a button so that the image appears later, whatever. That depends, of course, on your use case that you are implementing. With peak, it returns NOLL when it's not loaded, so it is not available in memory, or it returns the actual object when it is available and it is there in memory. So yeah, we can just return it. Instead of peak, which returns it, or NOLL, you can also use then, of course, is loaded to check, is it loaded, yes or no? And based on that, you do something, whatever that might be. Clear means that you clear the reference. So it is not removed from memory, but it is indicated for the garbage collector of the JVM that it can be removed when needed because of a garbage collection, a full garbage collection, for instance, which is running after you have run, if you call this clear, so then it will be removed. More a bit on technical implementations, what lazy is and how it is implemented in a moment. There is the last touch, and so every time you access with peek or get your object, your data, which is either available or not, but every time you access, then you have the last touch, because there is also an automatic cleanup. For instance, if the system sees, and more on those house holding processes this afternoon. But there is a process running that keeps track to see, oh, do I have a memory issue or almost a memory issue? I think the standard level is 80%. So if more than 80% of my memory is used, then I'm going to, as a precaution, remove all the lazy references which are not accessed during X amount at the last X amount of minutes, for example. I'm going also prepare them for cleanup by the JVM garbage collector, so that you preactively make sure that there are no issues with the memory, at least related to lazy objects. So I have then a lazy photo, which means lazy. So if I have in the constructor, I provide the list of bytes, of course, and then I can make a lazy reference out of that by using this static method. So that means that I encapsulated byte array list of purchases or whatever. I wrap it in a lazy and prepare it accordingly. If I'm just asking for the lazy object, okay, I can just return the lazy object, and I can perform there things like get, peek, clear, whatever. I can also, of course, decide to create a method which returns the byte array itself by immediately doing the get on the lazy. So I have two versions. I have two versions of the database. This is then, there was yesterday a question, is it possible to have two storage manager? This is for an example for that. So I have one storage manager which is linked to this MicroStream data with those 3 images, and I have one storage manager which is linked with that MicroStream lazy data, where there is the same 3 images, but then using that lazy photo. So the idea is of this example is that I, with some profiling tools, that I'll see what the effect is on lazy and non-lazy. The explanation is probably already clear what it is doing, but let's see it in action and verify that it is working as expected. So this returns all photos. This returns the eagerly loaded ones. This one return them lazily. So by default, it is not available, but I can call a load method where I call this get image data, which actually performs a get on that lazy, so which means that the system is forced to load them from an external, and then you can also see I've created here a debug method to with that is loaded to get the difference. So first things first, I think everything is already created. Target is there, so I can start up the runtime. And I can start up I forgot to do that, but it is here. Start up Azul mission control. For those who does not know it, it's a nice tool that does not only work with the Azure JDKs, but it works with any kind of, because it is that mission, the technology behind that mission control is open sourced by Oracle and is available in the OpenJDK, but I find that Azure mission control one most useful. Probably it's just a preference, any other implementation of that of all that information is as good as this Azure mission control. Then with these photos, I access the endpoint, which forces to load so it forces the storage manager, because it is not started by default, only when it is needed, and since it is not the lazy one, it also loads immediately those 3 images. So I get my 3 images without that binary data, the byte that would only mess up my console here, and it's not useful, but actually they are loaded, and the proof of that is when we take a heap dump, then we can see that within the ancestor of one of our packages, and again I have to remove quite some things here. Where is our, for instance, here are our images. Does not take that much because that's not containing the byte array itself. And I don't see it immediately, so that's why I'm a bit struggling here. because this is my database, my instance, but I should see here within these photos arrays, I should have a list to my byte array, but I don't see my byte array here. So there goes my demo. I did copy the correct one. Photos, not the lazy one. And I have the photos, so I should, to be sure, let's try again. Sorry for this. Let's delete this. Yeah, the first time if I run it, it is normal that those byte arrays are there because yeah, I load that image and I put it in memory. So now I'm preparing the database, which is normal that it is there because I've loaded them outside of my MicroStream. So I prepared the database. Which is not, or is there something wrong with the configuration then? No, it's MicroStream data. That's always the fun thing if you are doing more complex stuff. And, so the idea should be that I should see now linked to that list of photos that there was I guess during the weekend when I created the example, it was around 3 megabytes of binary data in byte arrays, so that it was showing that. But it is not so, and I'm not sure what is this. So yeah, you see there are still quite some byte arrays, but yeah, there are a lot of things stored in byte arrays, so that might not be the images that we are looking here. Okay, let's try with the second one, and if not, I'm afraid you have to believe me that it works correctly. It's also strange that it does not create a directory. So in the second endpoint, yeah, just lazy gets again the response, but since it's using that lazy, it should not load the images and they stay on disk. So if I just use here the lazy one, then indeed I get those 3 images, the information about those 3 images. Let's create a heap dump. So this is the before we have loaded. We go for checking for the debug. You see, for those 3 image IDs, I get is loaded from the lazy. I get false back, so it is not loaded. If I do a load, then my lazy references are loaded. So you see, actually, it is almost instantly that I get my commands back, so that my control back. So that means that between the time those 3 megabytes of data are already loaded from external storage, so MicroStream is fast. And then if I do debug, so my loaded is saying that they are loaded. So let's have a look if it actually shows up now there. So this second dump you see, linked to my photos, there is now a 2.2 megabyte of byte errors, which is the images. If I do it before I loaded the data, then if I go again to the photos, then they are not there. So I can actually request on demand the large binary data. So you can use lazy as a normal, it is just a pure Java object, so you can use it everywhere. You can use any kind of other type, so you can use it at the top level an image, or you can, for instance, here there is a document where the document is split under the different chapters. You have I don't know, a book, and where you have each of the PDF files for each chapter separately, so that you can load specific chapters one by one. So you can use lazy wherever you can use a normal Java object. As I said, creating here is to that lazy reference, so that whatever is as passed as parameter, you it's wrapped in that lazy reference, and it is correctly handled. Here, then you have a large, for instance, here are the books filtered, or sorry, indexed by the first letter of the name. So then you have, that's what I mentioned, how you can access, or you can access efficiently large record sets, the data sets where you might have millions, which is not a good idea to put millions of items in one list. Purely Java-wise, JVM-wise, it's not MicroStream-wise, but it is pure Java-wise. As I mentioned already, that gets returns the actual byte array. If it's not there, it's loaded, and with clear, and also make sure that you don't keep any reference yourself, and that's always an issue. Then with system garbage collection, that that byte array can be removed. So what is the how is it implemented? What is the internals around lazy? Lazy, that byte array here, lazy is built on top of the weak references of the JVM. So a weak reference means that the garbage collector is allowed to remove that at any time from your JVM weak if it's no longer referenced anywhere. So that's why it is important here that if you have a reference to the data itself, you should also remove that reference. Otherwise, the garbage collector may think, oh, I cannot remove it because that weak reference, because there is still some references to it. It is allowed to remove it. So it is not because, especially when you have those incremental, or how they are called, garbage collections that are running regularly, that it removes all those weak references. It is allowed to remove it, but it might be that it stays there for minutes because there was no need for the garbage collector to remove anything. So it can be still there, still be in your JVM memory, but actually you cannot access it anymore from your own Java code. Another thing that people sometimes do is then, like is mentioned here, oh, they do lazy image clear and they explicitly call system.garbage collector, and then they say, yeah, okay, fine, now I'm sure that it is gone. Well, no, because that's a JVM hint. You have to, for those that don't know it, have a look at the Java doc or any kind of other reference that describe the garbage collection. This is pure a Java hint. Most of the time, if you just do system.garbage collection here, it doesn't do anything at all. It's just ignored because it says, why should I do a garbage collection? Everything is fine with my memory. That's why some companies say in their development rules or coding rules, you should never write system.garbage collection yourself because it's not determined what will happen at that time. But point is that with a lazy, because it is based on weaker references, when you have set explicitly the clear, you have said, I don't need that image anymore from my side of the code. And as I said, make sure that you also remove any reference. Of course, if it is in a method, then this reference will be gone anyway after the method. But if you keep the byte array in a property of a class, then it can be lingering around. So make sure that everything is cleared to what the content was of that lazy, and explicitly say, I don't longer need it. And then it is the role of the garbage collector of the JVM to remove it. If you don't explicitly say it, because it might be the case that you say, okay, I have loaded it, but yeah, maybe the next request also needed, so don't throw it away because then it is a bit useless. You don't need to do that clear. As I said, there is one of the householding processes which constantly is monitoring these lazy references. That's called the lazy reference manager. If it sees, as I mentioned, that your memory is higher than, I think by default, 80% in use, and you can also define the threshold, it's already 15 minutes or longer than that there was a get on it, then the system itself performs internally a clear. Of course, if you have your reference yourself, that is not touched, that is not changed, of course. So that automatic process tries to provide the garbage collector as much as memory that can be cleared out, but be aware that all the references that you make to those large objects like images. There is already one question about, do normal references inside lazy reference consume memory before loaded? No. So here we have a lazy of byte. For this byte array, there is actually no assignment at all. So only the lazy instance takes some memory, that consumes some memory, because it needs to keep track of what it needs to load and those kind of things. For instance, it already has a pointer to the storage where that data is, so it can be retrieved very efficiently, but there is no assignment for the memory for that byte array at all. How about if the byte array is a subgraph of objects? The same. So if, for instance, there was a list in one of the examples here, there was a list of books. That book might have pointers to authors, that might have pointers to addresses. All those things are not loaded. They are not existent. They are not prepared in memory. They are not there at all. Just that lazy is available. The instance of lazy is available with the location to the list itself, or that byte array. So that it knows if you want to access the data contained in that lazy, how and where it can read it. And then it needs to traverse the subdirectory. You make sure everything is there in case of a list of books here, but it is not prepared, reserved, whatever in any way. It's only taking space for that lazy instance itself. Any other questions about lazy? How you can use it? How does it work?
I'm curious, how does a lazy reference know which storage manager to use to load the data in case it needs to be loaded?
It has, well, okay, I know what you mean, but actually there, each lazy has a reference to the persistence manager. So the persistence manager is the one who is responsible for reading and writing to those channels. So here with the get, it is known. Why it is known? Because this is the correct one. This is database. So when we start up our storage manager, and I can still maybe use that other image here, that graphic. Topics, as I said, those animations are a bit annoying if you need to go back and forth. There was that graph here where here. So initially, your storage manager loads your object model from disk. It sees that there is a lazy. So as I said, it creates that instance of lazy. Here it is available, but it also knows then which persistence manager it is capable of giving the data. And the persistence manager instance is then linked to the correct channels and knows where the data are.
I see. So that means that my object model can only reside in one storage manager, correct?
Yes.
I cannot share the root between storage managers.
No.
Okay.
Because that also would result in some conflicts. Because if you're
But it depends. If I didn't use lazy, theoretically, there shouldn't be any problems.
Yes and no, and yeah.
Because if the source of truth is my object model in the RAM, right? Then there shouldn't be any problems. But as soon as you use lazy, the source of truth shifts, of course, to a combination of both.
Correct. But then I'm curious what is the use case of having one object model which is stored by two storage managers? What is the advantage? What is the
that I don't know. I was just curious.
Yeah, okay. It's good to think about those theoretical cases, but yeah, no. Yeah, there should always be a one-to-one mapping. So
Makes
one
sense, yes.
object model, as we said earlier, you can have multiple distinct object models and with distinct storage managers. That's not a problem. But from the moment that you're going to combine things, and not one-to-one, but n-to-one or one-to-n or whatever, then you are likely getting into trouble.
Yeah, thank you.
So yeah, it knows the correct one because that lazy is loaded by a certain storage manager. So it knows, and so the instance of lazy here knows where it actually has a reference to the persistence manager, the implementation, not the interface as I showed you, but the implementation has a reference to the persistence manager that knows where to load the data. More good questions.
It's not a question, but I wanted to say that the lazy interface is very logical and clear. I think it's very good.
Okay.
I just wanted to maybe give the idea to mimic some of the interfaces of the Java 8 optional class with methods like if present or if not present, to pass on a lambda to operate on the instance if it's loaded and do nothing if it's not loaded, for example. And the reason is because it would mix well with the streaming APIs of Java 8.
I'm noting it down, and probably I will create an issue for it for a future improvement, or you can do it yourself. Everyone is free to.
True, good point.
Everyone is free here in the GitHub MicroStream, and then that's just a general remark. You can open issues if you have issues or questions that you don't know if it's working correctly or not, or that you see something that you did not expect, like that that you use it with records and JDK 17, but you also have a discussion where you can say, oh, what do you think about is present and is empty, or even implement the optional interface on top of lazy entirely, for instance. Then I have the only question: why is my non-lazy version not working? No idea what I've done wrong. But yeah, as you have seen, the idea is then if you take a thread dump, then accessing that information from the first time would result in that byte array available here, which is not the case here when you have it in the lazy one. But yeah, that's, I guess it makes sense that it works like that, but I have to check it out. So why my non-lazy version does not work.
Have you changed the singleton and the root and the main of the application? Well,
yeah, so I did this example. So I started with the non-lazy, and then I started copying things, and probably I did not test it properly anymore in the non-lazy version, where I messed up something with copying things. But yeah, it's
that's why static singletons are evil.
Yeah, but I have two different classes here. So, but probably with copy and paste, I forgot somewhere the lazy, or added or removed it or placed it somewhere wrong. Anyway, that's a general thing. Probably tomorrow it's a good thing to look at that repo here again with all the things, because there will be some last small changes also in slides, for instance, or in the code. There will be a text file that describes what each thing is. For instance, okay, makes most of the time sense, config backup what it is, but a few words of things, all those things will appear tomorrow or something. So it's a good advice. Go look tomorrow afternoon, or to see what is updated. There will be small changes here. Anything else about lazy? So lazy, two things, two major aspects that you need to know. How you can use it, that it is not loaded by default, that you need to do get, that it is clear, that peak, and those kind of things, and that it is based on that weak references of Java, so that if you are not holding references yourself, or explicitly do clear and those things, that it is nicely cleaned up by the JVM, and that at some point, so don't expect, because sometimes I also tried, so yeah, let's try to do something now and force the garbage collection and see if it's gone out of memory, and then you see, oh, it's still there, or you should take a thread dump, and then because the garbage collection actually is quite lazy. It only works when it thinks that it needs to do something. Actually, that was what I had before lunch, so we are a bit early, but that's not a problem. I think that was all the info that I wanted to give. Yeah, this is here. Yeah, how can you configure that? What I mentioned, that's automatic cleanup. And that's the lazy reference manager, where you specify, for instance, instead of 80% that you say, oh, let's kick in the process as of 75% and be a bit more lenient and not 15 minutes, but 30 minutes before lazy references are removed automatically. So this is how you can do it. That's also a singleton, and then because you mentioned there with static variables, what happens? So probably there is only one lazy reference manager if you have multiple storage manager in one JVM. So it works for both of them together, not linked to one of them for the cleanup. The loading works perfectly, but here for the cleanup.
That's interesting. I would have expected that to be part of the configuration.
Yeah, that's also maybe things that I'm making notes. Always good to have feedback. So the next topic we will handle is about how can we implement changes to my data model. Just as with a database where you have changes once you are in production during development, that also happens, but it's less important, less dramatic, because you probably can make those changes much easier. And so also as with the database, once you're in production, for whatever reason, you need to change properties, you need to add them, rename them, remove them, do larger restructuring of your data model, create new classes, split classes, whatever. So how can MicroStream handle that? How can we keep our original data or existing data, but convert it to that new format? And to understand that better, we are going also to have a look at how MicroStream handles those data types. So if we have a class like book, and we have already looked into that type dictionary yesterday a bit, but a bit more in detail now of how that type dictionary also helps us in migrating data from one format, I mean from one class to another class, and from one version to another version. And what happens then if we make those changes, properties, is that a lot of work is, do we need to do anything at all or not? Maybe let's see what we need to do. Because it happens to be the case that MicroStream can handle some of those changes automatically without that we need to do anything at all. So that's a good thing. Some things can be handled automatically. The simple things can be done automatically. The more complex ones, you need to write those legacy type handlers and the legacy type mappers. Most of that stuff is for the advanced training, but we will start laying the basics and showing what is possible automatically by MicroStream without that you need to write code, that you need to do a conversion, and that's then also the basis for the advanced training. So we have seen that that type dictionary that you have there for each class. There are, including the primitives, and for basic classes, there are numbers assigned by default if they are used or not. So because probably you have an int, an integer, or a string, etc., everywhere in each program. So we assign some unique IDs to some of those basic Java types automatically, immediately. And for each class that it then encounters, for example, when you store or when you initially create a storage manager based on that root object, for each of those classes, it also generates unique numbers like that number 1,000,066 for that customer with the properties ID, last name, first name, male, and gender. The previous trainer did some nice homework, and if you look at the binary representation, then you can find all those IDs there, and if you store an int, then you can find that information there in a binary format. Also for your own custom classes like that customer, you can find that information there. So if you know the internals of that binary representation, then you will see that, as I mentioned already, that within that binary representation, we only store IDs of some types like customer, or the ID, then the last name of that customer, and the values. So we never store the actual entire class name, nor do we store the structure of your Java objects in that binary format. That helps us for that, for all those security issues, so that when you're reading a binary format, then if you manipulate that you cannot load any random kind of class in your JVM, which can be harmful, especially because we have those within the standard JVM, we have those classes, those methods that allow that are executed after your object is loaded and before it is handed over to your coder, so that there stems all the security vulnerabilities. So in that storage, we have only IDs, and the type dictionary is the key to decipher it. So the type the dictionary and that each class gets a unique number is the key. Well, it's not a class that gets a unique number, it's each version of a class, as we will see. Yeah, so that's the explanation of the text. So that's how we store it, and that's also the key for evaluating your data model. Yeah, there are a few links to what data types we support. As we all already mentioned, we support all Java objects, no matter what format. Sometimes we need a specialized handler, as I mentioned, to make it more efficient. Sometimes to avoid some things which is hidden, like we encountered also with those records, those Java records that we need the unsafe class to get access to something. So but in theory, we can handle all kinds of things. That's our job, to handle any kind of Java instance in your data model. But what if what happens if we add a attribute to that customer? For instance, here at the bottom, we have a new attribute called IP address. So that's then, for instance, the last IP address that the user that our customer used to access our application, because that then can give us information about the area where he's living in, etc. I know that's not safe at all in the sense that with those VPNs you can be in any kind of part of the world, but it's an example I have in the demo, another example. If you look then at the type dictionary, well, actually, you will have then the same class twice, but with two different numbers. One with a structure where you have that IP address and one's without that IP address. So as I mentioned, it's not a unique ID for a class, it is a unique ID for the class version. So that's an indication if there is that number 67 in that binary format, then we know that in that binary format we have stored at that time something which has a property called ID, last name, first name, email, gender, and IP address, and the types here all string in this case. If it's 66, then it is again the same customer but without that IP address. That's also the basis why you can have in your data storage data which belongs to the old format and the new format. More on that later, but keep in mind that in the storage you can have some mixed versions. So it's not an all or nothing like in the database. If you add in your database table another field, then that field is available for all records. It's more like the NoSQL case where it defines that version identified by that number has that IP address available, that other version does not have it. So, and you can have both versions at the same time in your storage. Again, in an example, but that is not really important here, but you can find all that information again in that binary format. So there are some changes that MicroStream can handle automatically. So we start on the left side, we have a contact with properties name, first name, age, email, node, and link, and the types. So we have created lists out of that, single contact, it does not matter, but in our storage, we have then a binary representation of this contact with all the properties. We stop our program, we change our class, first name was moved. It was not on the second property anymore, but the first property. Name became last name, email became email address, etc., etc. So we have a new object, even a new reference postal address. We have renamed a few things. We did not delete anything, but we can do it in the demo. What if we start up our new program, the program with the new version, and it tries to read data which is stored in the storage with that old format? It looks, it scans that binary, and it sees there, going back to the values before, it sees there, for instance, for that contact number 66, and sees that it is a contact. But it also determines then that at runtime, because you're running that application at that time, your contact, your properties does not match those which are in the type dictionary. Because in the type dictionary, there is still that there is a name, first name, etc., and that does not match with the Java class metadata which it sees at that moment. if it encounters that situation, then it tries to find a mapping. Sometimes he will succeed in that. Sometimes he will give up and saying, well, the data cannot be matched, and then you are in the advanced case of a refactoring of the legacy type mapping, and then you need to help the system, then you need to help MicroStream by implementing some handlers that says what needs to be done, because he cannot figure it out himself. But in this case, between old and new, he can find out what is happening. Talking for 2 days, start having a stall. So first, it tries to map all the properties which have the same name and the same type. So it sees that it is, it finds still the first name and that age, okay, that it is placed in another order. That's not important for our binary format because yeah, we know the order and it is in the binary because that's defined by the type dictionary. If it's in another place in the current class, yeah, then okay, then we need to make sure that when we allocate that memory for that contact, we put the correct reference at the correct place, but that's not the most important issue. Once the properties which matches are identified, it tries to find a match for those that are not matched. For instance, name that was not there anymore, so it tries to find something in the second class that can match what the system thinks that you have renamed it. And it does that by calculating the word distance. I forgot to look up the name, but there is a certain metric that defines how many characters there are different, etc. there, and that gives you a value between 1 and 0. And based on that, he tries to find the best candidates. So the most likely candidate that that you have renamed name. Since most of the time, like here, you go from name to last name, he will find out that you have done name to last name. Same for email address. He figures it out that it is the same. If that is not the case, then of course you still need to write that legacy type handler yourself. But most of the time, email, the intention of the developer was that email is now email address. Note, that's already a bit more tricky, but eventually he finds out that it is support node because he tried everything else first and then he sees, yeah, okay, support node is the best candidate. For link, he also checks, finds that there is nothing anymore that in any kind of similarity that has any kind of similarity with the names that you are using now, and he decides that link is removed at all. The same for that new one. There he does not find any mapping, so he finds that postal address is new. So if you would, and I would, based on the demo or yourself, I should suggest that you play around with these kind of renaming yourself during your first days that you play around with MicroStream to see how it behaves and what it can do for you, and see how far you can go. If it's finding it, yes or no, and so that you are learning about those heuristics that tries to map the one. If it finds such a difference between what's in the type dictionary and what's in the Java class, he always puts an output in the logging entries, saying that there was a legacy type, so the old type, legacy systems, old systems. That's the link that we have. The old version of contact, which had number 55. It maps it to the new version of contact, which was known in the type directory as 56. That can be number 348. It doesn't need to be a consecutive number. And it gives you the mapping that he calculated, and with the statistics of probability. So yeah, first name was mapped to first name because yeah, that was a 100% match. So that's why it is probability 1. Name, there is only 75% probability, but he decided to map it to a last name, email to email address, node to support node. See, there is already more difference. It's only 63%. He also found that there was something new, postal address, and he also says that that link is discarded. Here is the right yes to accept the mapping. That's an option, which is of course not always useful, that you confirm what he has proposed. So when the storage manager starts up, he actually asked on the console, do you agree, yes or no? You have to specifically indicate that he should ask you that. If not, he just assumes that this is correct and he starts working, which is not a problem if it's wrong. I come to that later. Why it's not very useful in most cases? Well, if you start up your program, you not always have access to the console where you can say yeah, yes or no, so that he can continue. So, but it is there mainly also for testing purposes, but more on that, something in the best practices at later today. So this is the explanation that I did. So it works in this case, even if you already think, well, that's a pretty dramatic change that I did to the contact, but he's still able to find out the correct links. If you're doing it during development, then probably it should be better than you just drop the entire database. That's most of the time just deleting your directory, and you initialize, as we have seen now already a few times, that you initialize your data structures with some test data or basic data. Then it is, of course, it is better to, as I said, drop it and let the system generate immediately the proper new test data, but it's not required, of course. If you're working with production data, yeah, always make a backup, of course, so that you don't lose any data. But as you will see in the examples, it is not the case that it sees that there is a different class, that your data is either lost because it cannot read it, or is immediately converted. We will see that in a demo. Perhaps I do that first, because it will show already what I have explained and give you more insight. If there are any questions about it, please interrupt me. Yeah? You know, I'm just continuing when there is no real question. I have something similar as a demo here, and it's also it's not in that training repository, but I will put the link into it. Is one of my other repositories that I used for a blog. So there is also a blog around it, around this one, and the example of that is there. So I'm reusing that one, but as I said, I will put some text there in the repository, which will also link to this one. The old version of the lead object, so we have we are creating some CMS system, and we having name and the quality of the lead, the email, some notes and references that people make, and notes from what we have discussed with that person, and the reference is that it was at the JCon conference or the VR developers conference or whatever. So that was the idea of that field. First, I will show you the new version, and then let's start the program. So the new version, we changed the name to contact name, because here the lead name that was not that clear, so we changed it to contact name. And we removed the property reference because everyone was putting the comment, spoke with him at VR developer, so they put it in the note anyway, so that was a bit useless, so we dropped that. So if we have here a program, and again, it is we start an embedded storage manager. If there is no data yet, we do some initial values. So we load two values in our the database, and we can print it out. So we run it the first time. It creates the database and prints out, of course, the two lead names. Correct. When I run it the second time, then it just read it from the database. So so that you can see that it is 100% certain that we are reading this from this data directory here. So we have two entries in our database. Our new version of the program does exactly the same. So it starts the embedded storage manager pointing to the same data directory, of course, the data storage, and it prints out the new version. If I run that program, it tries to load it. And as I mentioned, he prints out I'm going to make it a bit larger. So it prints out, as you have seen on the slides, the difference between version 69 and version 70. He mapped email to email, name, contact name, quality, because that's the same name. The note was also the same name here, and he saw that we removed the reference. So again, the heuristic did fine, which means that he prints out now the contact name, and of course we don't have that reference here anymore because in our class we have removed that property. Did the database change? Did the storage change? No, not at all. So if we start our old program again, then we have everything, including what we think that we have deleted. So it is still there. So our program, our storage manager, can convert on the fly structures, information, data, which is not in the exactly the same format as our Java classes, but it can do a mapping automatically, which means that he can read the data in the old format using the old program, but also read it with a new program where he performs that mapping automatically. So I can read it. So what happens now when I update a value? What happens, or what do I need to do so that the entire database is converted to that new format? So suppose that for my entry here, I will update the node. So I'll update the node to new content, and I store it. So that's here behind the scene, update node. It says node, and with the persister, with is actually the subsystem of the storage manager, which is responsible for saving. So we can, instead of using the storage manager, call the persister itself, but that's not really important. Point is, if I update the node for myself, so that means that I have now updated the node, and I have then the data in the new format, but only for that one entry. We did not store everything, but the new program still can read it. My updated version where I have my new node content, and the old version, which is still in the old format. And we know that there is still an old format because you see, he says that he has done a mapping. That's in this case only for that one entry, not for the second one. But that also means that we can run the old program still. And there happens something else. Namely, he tries to map the new format to the old one, which is here in this JVM class. Which means that, yeah, the reference is null here for the second one because we stored a version where we don't have that reference, so that the reference was filled in initially. We updated our object, but yeah, we have lost it now because we have stored it with a version where we did not have that reference, so that's gone. But the other one, the other entry, which is still in the old format, still has the old data. So that's what I mean, that MicroStream can handle storages where there are mixed versions of your data. So it's not required that you immediately update your entire database. You don't upgrade your entire database, that's not necessary. You can do it, of course, probably a bit faster, but it's not needed. So and that gives you also the opportunity to go back. How do you convert the entire database then? That can be done by, because this storage manager reads again the entire database in this case, because it's just one list. And here, yeah, I store the root itself. I could have stored the list of leads, which is in a production system probably a huge difference. Here it's not. But using that eager storer, I make sure that because there is no change here, I forcefully store everything, which means that it makes a copy of what's now in memory and adds that to our storage in the entire new format. And remember, a storer, you need to first to store and then commit, because otherwise it's not working. So this actually can be used to convert our database. Our new leads program, which has removed the reference and has that contact name, can still read both. Our old program, you guess it, correct, can also read it, but of course, reference is no longer in the storage for neither of the two entries, so that means it will be NOL. And normally we should see here also that there are still two versions of the same program, of the same class, sorry. that's the entire story of the automatic migration of your object model that can be done by MicroStream. Automatic in the sense that if he can find out how the mapping from old to new goes, then yeah, he can do it, and you can always try it. If it fails, that's not dramatic, because your storage is still in the old format. Only when you explicitly store something individually, one object, like we did here with an update of one entry, or we do a store of the entire object graph, like we did here, and only at that point we have changed all the entries in our database. Any questions around this automatic portion of the legacy type mapping?
So this automatic mapping, is it stored in the database itself? Like the fact that email now is email address, is that fact stored in the MicroStream's database?
No, we calculate it every time again based on that word difference. It has a name, but
It's probably Levenstein's distance, I would guess.
Yeah, just correct. Based on that, it calculates that over and over again. Only at startup, so it only needs to do it at startup. So yeah, it is an overhead, but
no, there's a small risk that a new version of MicroStreams could like improve maybe the automatic heuristics, but it's now different than it was before.
If we change a heuristic, then we might come up with another mapping. Yes, of course. So my suggestion is that eventually, that does not mean that you need to do it immediately, but eventually that you update your entire storage, because that's more performant in any way, in all the scenarios, because the system only encounters binaries which are in the correct format, which are which has the correct structure, which is identical to the Java class. So it does not need to calculate those distance values. And yeah, of course, it is a bit easier when it just needs to take the values and push them into a heap reference instead of trying to figure out what it needs to do. But so I don't say that you should keep 2, 3, 4, 5 different versions of your lead object in that binary representation and say, yeah, eventually it will be okay, because yeah, maybe it was okay if you switch from version 1 to version 2, but maybe no longer if you switch from version 1 to 3. But it was okay if you do it from 1 to 2 and 2 to 3. Those could be done automatically, but not, for instance, between 1 and 3. See, it is good to try it out, that you're not forced to do the conversion immediately, which might change your data in a way that you cannot recover. That's also the reason why you should do a backup. But you can start it up, you can see if it works, yes or no, and then probably do the conversion, the entire conversion anyway. Does that make sense, what I was saying?
Yes. Just one thing I don't understand yet is, at what point does MicroStreams tell me that the automatic mapping has failed? Is it when the data is used, or at startup every time?
Since it tries to load the data at startup with your when the storage manager starts, he scans the entire storage, because probably he needs to load a lot of the data anyway, except for those lazy references. But at that point, when it starts, when the storage manager starts, at that point, he verifies the versions, are they the same? Does the mapping is possible or not? So if there is an issue that it cannot be solved automatically, and sometimes they are, especially when you're creating new classes, or you split one class in two classes, etc., and you make a reference from one to another, then he's completely lost. You will get notified about that when you start. So here, and at this start method, it will throw an exception saying, sorry, I cannot read the data.
What about lazy references? Are those ignored or also scanned?
That's a good question, which I have to look up.
Okay.
I assume they are not handled at startup, because that would defeat the fact that it is lazy.
Well, it can scan the schema without loading the data, in theory. But
yes.
I don't know.
So, yeah, I have to check. If we put this example in a lazy entry to see what it does, but yeah. No, I have to check. I can speculate, but it's better that I can that I check. But one thing that for sure, if the storage manager can be started fully, it's fully operational, maybe except for those lazies. But if it's able to define that mapping as you see here, then it can handle the data. It's not that during accessing, like here, accessing the information, that moment it says, oh, sorry, I could not use a certain element. I'll make a note of that, of the legacy, automatic legacy type mapping with lazy.
Also, do those old classes in the PTD file, do they eventually get cleaned up if there's no data in the old format anymore? Or how does that work?
No, this file is never cleaned up. These binary files, they are cleaned up. I'll come to that in a moment. That's one of the next topics. But this file is never cleaned up. So yes, eventually there will be this entry that is redundant, but that's not cleaned up. Just as the same fact that you can have, for instance, if you don't use an hash table, that's now the MicroStream one. There is some, if you don't store a pattern, a regular expression pattern, or an internet address, you see it is still there. So this file is, this persistent type directory is never cleaned up. But okay, I guess there is not that much redundant info. Okay, this is a bit redundant, but it's not that probably not that 80 or 90% of the file is redundant. So that's the example. I cannot click it here. But I will put a link in a text file. There is MicroStream legacy. So that automatic case is the one You also have a manual one and a complex one, but that's for the advanced things because there you have to write code yourself. Any questions about this kind of migrations of your data model?
Not at the moment. It does seem quite a lot of material for today.
Yeah, it's a lot of small things today. But if you already know the principle behind it, then I guess you can work with the material that you have to get an idea how it works. Next thing is the backup. So let's go over all the animations and the slides. To go to a backup, what are backup strategies? Yeah, when at some point the persistence manager and those channels, etc., cannot write anymore to the storage. For instance, you have defined a database or a cloud, and there you have, of course, also network and routing. If at some point those sources are no longer accessible due to a network interruption or whatever, then of course you get an exception in your program that it no longer can work, and then you have probably a fatal error, which means that your program stops. But backup strategies can also be nice to have, that you have a copy of your data at some place. And I guess that's perfectly fine because your data of your application is the most important thing. If you lose all your data, then yeah, that can be a disaster. So you need to have some copies, and having a copy already when it writes, so that you have a duplication of everything at the moment it writes everything, that can be already a reassuring thing that, okay, I have an additional layer, an additional measurement to keep my data safe, that I don't lose them. Also, things can get corrupted. It does not happen that much with disks anymore, but I remember when you had those floppies 15 years ago, it was not reusable. You could just write it once and read it never again, because at the end they were so, quality was sometimes so pure, so badly that you can only write to it and never read it again. So okay, that does not happen anymore now, but to protect you, that you can create a backup, and that backup you can have two different kinds of backup. But I'm here specifying, which is not 100% clear from the slide, so I need to add that. You have two things. You have either a full backup or you have a continuous backup. A full backup is that you make a copy of the state as it is at that moment, and yeah, you copy it, the entire storage at that moment. Or you have a continuous backup where after you have written it to one storage, you write the same data also to a second storage. So it's only serialized once. So the objects, the Java objects are only serialized once to that binary format, and then stored in one storage, and immediately after stored in a second storage. That backup storage then, of course, has always the same configuration at the same, especially important, the same number of channels, but also the naming and what's called the blob sizes, how large can a file be until a new file is created, etc., etc. So all those configuration settings are identical for the primary storage as the backup storage. What can be interesting is that the type of system, the abstract file system, that it can be a different one. So you can make a mixture of disk and database, for instance, so that you write your primary to disk, because that's maybe faster, probably a bit faster, and your backup is then written into a database as a blob field. So you can make a mixture. It's of course not needed. You can just say to disk, and the second one is also to disk, but you can make a mixture. The only thing what needs to be the same, and you cannot specify otherwise, if you just make one configuration like channel count and naming, etc., and that is used for both storages. That's the incremental or the continuous backup, so that is performed all the time. Every time you do a store, it is written to that bucket storage. The initial storage, the initial backup strategy that we had in, I think, version 4 or something, version 3 of MicroStream, was that you could create a full backup. So you explicitly issue a command from the storage manager. As you can see here, storage manager issue full backup is the command, and as a parameter you specify a location, for instance a directory or a any other kind of abstract file system implementation, and at that moment your entire system is copied from the primary one to the secondary one, which was and is good maybe for some smaller cases, but if you need to copy, I don't know, 10 gigabyte of data, but of course that takes a bit of time, and during that full backup you cannot store anything else. So this is a blocking operation, just as a store is a blocking operation, so that if that issue of full backup is launched at a not so optimal time, then of course you have a performance issue for all the requests that try to store something. It might still be useful, but the idea is that you should implement that incremental or that continuous one by just specifying in the configuration, this is my secondary target, and then it is used all the time. The program is stopped because it was just a Java SE program. I have here a backup. So let's start with the full. So we have our normal storage manager again. We create a root. So that configuration is, there is nothing specific. We only say the standard storage directory. We don't indicate any backup here. Then we write 1,000 numbers to a list and we store it every time. I'm trying to simulate something here. You will see what I mean. Then after those 1,000, I issue a full backup and I put here some timings, but of course it just copies something in the database, which is not that huge. So it's not that amount. It's not that impressive for timing and for performance reasons, but he makes a copy of that, and then he stores another 10, and let's simulate a crash and see what happens and how you can use then that backup for instance. So, and here at the beginning, yeah, in the beginning it says how many items we have in the storage when it starts. So we run it, it stores 1,000 items, it makes a full backup, and then system exit -1, some kind of crash, which I simulated. So store contained nothing at the beginning. You see, to copy the full backup took only 17 milliseconds, because I said it is not that impressive, but I have here my original data, and I have here my backup data. So suppose that we had a crash and this is gone. Then of course, if we start up like this, then yeah, we would have lost everything. So those 1,000 numbers that were stored and those additional 10. If we just copy, and ideally, as you should also copy that type dictionary, okay, they are now the same, that would not be an issue here, but yeah, I should show you what you should do in a real production situation. So if you copy then your backup there, just like I did here, and you run it again, then you see that your store only contained 1,000 items. And I have an exception. Okay, because he cannot create a backup because there was already one backup at that location. That's not the main issue for showing what I wanted to show. The idea is that, as expected, I created a backup at this moment when I had 1,000 entries. So those last 10 entries I have lost. I no longer have those entries available. We also have that continuous backup, as I said, which is recommended, where we have the configuration and we have a directory for the main data, and we have a directory for the backup. You can also, in the more, with the foundation, you can really specify if it's a different one. Remember, this builder is suitable in most cases, but for instance, for having here a backup within a database, you need to create that. You need to start from creating a foundation, etc., and there define where the backup is. But here it is fine, just 2 directories. And yeah, just for keeping 2 programs as similar as possible, I just do it first 1,000 times, and then the next time I do it 10 times, and again simulate a crash. Initially, it contains nothing at all. That's something what you can expect. And I have here data in my backup, and I have data here in my primary source. Suppose that for some reason there was a real issue and I have to delete it. Then I can again put this there. And let's see what happens if I again do this backup, if I delete also this entire backup. So I have a backup and I use that backup as a primary one, but then I can safely, as you will see, safely delete that entire backup again. 1,010. Let's see if that's correct, because it was continuous. The crash did not impact anything, and that's something I did saw yesterday also. And I was wondering, why is that last one not written? But okay, it's something that I have to look into. So we have at least all the data, or should have all the data up until the last moment. And you see he has also populate the entire backup again. So even if the backup is not up to date with the main data, he makes sure that when it starts up, that the backup is again in sync with the main. So it's not that this continuous backup only contains then the data from the second run. It also again contains the data from the first run. So that's a nice thing. The only thing that I have to check out is why we are missing the last one in the backup. Because my idea was that, or for what they always tell to me, is that the store is blocking until everything is done. So my idea was that it was also regarding the backup, so that it's not returning until the backup is also fully updated until the last one, which seems not be the case. Any questions about backup? So incremental is the best option, of course. It's also the newest one. Next thing is, yeah, okay, I mentioned crash safe. Yeah, the storage manager has that shutdown method. You can it's implementing auto closable, which calls then this shutdown, but actually that shutdown is not required at all. Once a method returns, all data is persisted. So as I said, if store returns, everything is fine. We are sure that it is stored. Of course, not all APIs are crash safe. I remember that eager and lazy storer, there you have store. If you don't do a commit, then you don't have the data saved. So if there is a crash between the store and the commit method, then of course you also lose some data.
I have a question here. So for example, when we ask JVM to shut down using any signal, for example, Control-C, then will it gonna shut down the store manager as well, or will it listen to the shutdown hook?
No, if you need that, then you need to implement your shutdown hook yourself, which I'm always forgetting that I cannot select it. That forwards to the shutdown here, but normally, yeah, of course, until if you kill a process which is just in the middle of here between a store and a commit, then that's a problem. So if that is the case where you're worried about, that, for instance, a shutdown of your process should first continue with what it was doing, then you need to implement some protection logic yourself, so that the shutdown is not happening in between these critical phase between a store and a commit, for example. Most of the time, and then I'm thinking about those cloud environments like Kubernetes, etc. There you can, unless of course it crashes because of out of memory error where you do not have many control over, but you can have most of those environments like Kubernetes, you have something like a graceful shutdown of your process, which means that there are no longer requests sent to that process, to those endpoints. And when all the requests are handled, then at that moment there is a shutdown, so that you have a proper stop of your system. And then again, it is no problem for MicroStream.
So in that case, even graceful shutdown, we have to handle shutdown by ourselves to completely implement our logic. For example, if we want to take a backup or shut down MicroStream properly, we have to implement that by ourselves.
Yeah, but since in normal cases, when there are no requests handled for the users, which means the no store method is going on, then it does not matter if the process stops or not without a shutdown. Shutdown is not needed to flush anything to the disk. After a store, the storage manager store, this store, after this store is performed here, everything is sent to disk in this case. So if there are no processes, no requests handled for a user, that means there should be no store going on, then it is perfectly safe that your runtime, your process stops without a shutdown. Here, I always do it like this within a try with resources block, because this one here is implements auto-closable somewhere. It's not here immediate, so because then otherwise in IntelliJ always says, hey, you are using auto-closable without a try with resource. But actually in runtimes like Spring and Quarkus, etc., we never or almost never have a proper shutdown, because when the system is not handling a request for the user, it is just fine to kill the process. Question is that each storage manager has its own backup file. Yes, you add, so that is here within the configuration. You see that with each storage manager you define, besides the primary, also the backup one. So it is here it is for each storage manager separately, that you have a separate backup location. More questions around this, or are things clear for the moment? Is it the case that the database and the backup, there's a question about database and the primary database and the backup are both in like S3 buckets? You mean that data is written automatically immediately, or what do you mean by if you're using an S3 bucket? Otherwise you can unmute yourself if you.
Yeah, that's more easy. I'm just curious about when you do your database in like AWS S3, do you also do your backup over there, or do you have to split it up in like one S3 bucket and another S3 bucket for both your backup and your vendor, maybe like Azure? Do you backup by Azure and what's
it's not if I'm correctly, it's not possible to define the backup in the same S3 bucket as your primary, but you can, of course, define your backup in another S3 bucket. But I think within the configuration of S3, you only specify the name of the S3 bucket itself. And of course, the connection and all the credentials to connect and those kind of things. But I think it's only the S3 bucket name itself you specified, so you cannot specify like a subdirectory in that S3 bucket as your backup. So that means that you need to specify your backup in a second S3 bucket.
Okay, thank you. Yeah.
Other question, what will happen if backup storage IO speed is much slower than the main storage? Well, I was under the impression that that when you do a store here, this one is a store, in the continuous one, that it saves it to the primary one, and secondly, it saves it to the backup, and then your program gets control again and continues. Based on what I see here now, I have the impression that the backup is performed asynchronously. That saving it to the backup is asynchronously, but I have to check that within the code. So that means that it does not really matter. Well, it does matter, but if for the performance itself during normal operation, it does not matter if the backup storage has a much lower I/O throughput, because that would not hinder your performance of your application itself. But of course, it can be an issue that your backup needs to catch up and that it might not contain the last version, like it seems that we have here. So probably we have some time, so let's play with this, and then I can immediately confirm that the experimental way is also a way to find out if something works by putting a sleep here. So without a sleep, it was 1009. So I'm expecting that there is some additional time needed to catch up for the backup so that it is done in a separate thread, which will be confirmed if I see 1010 here now as an output. And there it is. But I have to confirm it with the developers if it's actually the case, but my idea is yes, which means is I/O of the second storage important? Yes and no. Yes, because you can lose data if your crash is immediate at some point, but no, it does not impact performance of your primary process. Unless there is, of course, another question, I can continue with the next thing about housekeeping. I mentioned already a few things around those housekeeping, etc. So let's put everything together on a few slides so that you have an overview of what's happening behind the scenes. If we store something, we only store changes, that's already mentioned. And it is also appending the changes at the end of your storage, at the end of your file. And the original block that contained your data is marked as obsolete. So we are not really using blocks in the sense that, for instance, disk use blocks with fixed block sizes. But yeah, we have blocks of data from different lengths in that binary format, and we can mark such blocks as obsolete, meaning that they can be removed. You will see it in a moment better. Why adding? Well, first, why only changes? Well, I guess that's what we mentioned yesterday already with that lazy storer. It does not make sense if you have 1,000, like we have in our list, if we did backup, if we have 1,000 items in our list, we add one that we store the entire list again, so that we store 1,001 items again, because yeah, there is only one change. So it takes a bit more of CPU time to define if something is added, changed, or whatever, but it saves, of course, I/O time. And since CPU time is much cheaper than I/O time, because you have that latency there, so that's why we prefer to specify another algorithm to define the differences and save on things on I/O time. And also we gain some performance and some speed by just adding it to the end, instead of oh, where was it located in that file? Oh yeah, there. And then, oh, but now I need 20 bytes. And before it was only 15 bytes. So that means that everything behind it needs to be moved. So that would be a nightmare. So that's the reason why we just say add it at the end of the file. A bit like Git does. Git does also save changes. And yeah, the system needs to figure out what the eventual, what the end state is based on the original data and all the changes that you have done. So the same is here also for MicroStream. If you're wondering, that part of the system is already 10 years in production. So that works fine. So we don't believe that there are any bugs around that part that makes that your reconstructed data from that binary storage is in some way wrong, that we restore something incorrect. That's something that we never encountered the last several years. But of course, adding to the end of the file means that your file grows. So suppose that you're continuously writing to that file and eventually also creating new files. But if you would continuously write to files, that would mean that your disk is full at some point. So we need to have something that tries to keep the storage as small as possible. It's not the smallest possible, but as small as possible. So some animation to show it. So yeah, all the blocks on the right in the storage are all 0, 1, 0, 1, 0, 1, but suppose they are differently. They just represent a binary block of data, and as I said, they are not all of the same size. But if we change something in our graph, so it's highlighted there in our object graph, we change a few things that needs to be stored to the storage again. And that corresponds to that block there, which means we mark that block as invalid as part of the store operation. And we add at the end the new version of that content to the file, and everything is okay. That can go on and go on for days, minutes, hours, and of course that depends on how many changes there are. But regularly there is a process which scans all the time, and which scans those storage structures and see if there are many obsolete blocks or not. That's also part of that configuration and the min file size, the max file size, etc. I think I saw it here also. See, we have here already 3 files because we have added always added one. So the number of files can grow a bit, but there was no time to run the housekeeping process, probably because it was not a long running process. Probably this content is entirely obsolete, that you no longer need it. Yeah. If that's the case, then that file will be removed eventually. It's also possible that we do a reorganization of the file, just as the garbage collector does within the JVM. So there are several housekeeping processes, and one is one process runs within the channel. I remember the channel which is responsible for serialization and deserialization and the I/O. There is a storage cleanup housekeeping process, which makes sure or tries to make sure that your storage is as small as possible. So that one is responsible for cleaning up old files for cleaning up the files itself. I made an example where I continuously write, so CPU is 100%, I continuously add some values like in this case. Where I continuously add something, then, and if you play with that, then you will see that the number of files continuously grow. It does not have enough time to perform the cleanup. Because there is a configuration for that cleanup that says, which is configured by an interval and a time budget. For example, every second, this cleanup gets 100 milliseconds of time for performing that cleanup. But of course, if you have so many writes, have so many changes that, yeah, the cleanup process is not able to complete that work in that time budget and interval that you specified, then of course, yeah, your file system gets fuller and fuller every moment. The default values are more than enough for standard operations, which means that you have user requests every, you can have an X amount of requests per second, but you're not continuously, like in my example, where I put here something, I don't know, I think it was something like 100 million or something like that. So I was continuously writing for 30, 40 seconds. And then, of course, the system does not have enough time because I was constantly writing to that storage. So that time budget that was allocated by default was not enough. So you can define that interval and that time budget that set every second so many milliseconds, for instance. So you can shorten the interval so that the process runs more frequent, or you can increase the time that it can run each time by defining it in the storage housekeeping controller. You can also, if you search for this word in the documentation, then you also find it, the settings to do it. Another housekeeping process is within that lazy reference manager. We explained it just before lunch. That internally, when the system sees that you have a certain memory quota already used, and so that it might be that your JVM process has or is risking to have a out of memory error, that it proactively starts freeing up those lazy references so that it's only a weak reference anymore, so that there are no hard references anymore by MicroStream kept, so that the garbage collector can clean them up. So that's a process that also runs, and that's continuously, well, not continuously running, but you cannot configure how many times it runs, but you can configure the parameters of when it should consider a lazy reference to be cleared, as we mentioned before, based on the memory quota and the number of minutes that it is not used, that lazy reference. That's the second reference. That is the second housekeeping process which is running. The third one, which is now with version 7.1 activated by default, and before it was more or less an experimental one, where we have implemented our own garbage collector, which of course is a bit a dairy undertaking. Well, it's not a JVM garbage collection, process that we have created, but we have done some implemented the process that cleanups within the within everything related to MicroStream itself. Remember, we have we mentioned that we keep old and new references to make to see if things were changed. So that's also working on that area. So in that cache, we do a cleanup and we see that it is no longer used. We also running within the storage files and other internal structures to actively removing those blocks. Remember that a block can be marked as obsolete in those storage files, and then it can then, if a system see that all blocks are no longer useful, that it can delete the file. Well, now we can also spend some time in removing those blocks and compacting the file to a certain extent. Of course, we are not going to waste a massive amount of time to every time shrink a file, but we are helping there the other housekeeping process to keep the things as small as possible, as clean as possible. So those are the three main housekeeping processes which are running. Of course, the most important one is the storage cleanup, so that files are deleted, that database records, if you store it in a database, are deleted, and then of course here the lazy references. If you don't use an explicitly .clear yourself, then that those things are cleaned up by default. Any questions around this, or are we good for another 10 minutes break? All good. Then I propose that we come back at 25 after the hour, so that I try to get my voice up and running for the next hour and a half or so, because it starts to fail. So see you then in 15 minutes. Hello, everyone. I hope that my voice lasts for the last hour and a half or something. Probably not. I don't have not the material prepared for the entire hour and a half, I think, but we see if there are no other questions or what we can cover. There was the question of where can I find a way to connect to the S3 bucket. Yeah, backup or not, that's more or less the same. I will go briefly show it to you in a moment when I cover a few of those connectors, and then I'll point you to the documentation for the Amazon S3 one. Anyone for the moment a question, or do I continue with, actually that was one of the questions that we had yesterday, to talk a bit more about integrations that we have. So basically there are two types of integrations available. I call them two types of integration because I don't have another name for it. There are, on one hand, MicroStream is integrated, included, not only integrated, but included within Helidon and Micronaut. So since last year, somewhere, I think around this time, I think it was just after the summer, in Helidon 2.4, it is included. So
sorry to disturb you. When you say included, what does it mean?
Included means that that there is a MicroStream version available in the runtime of Helidon itself, within the runtime of Micronaut. So you don't need to add it to your application. It is already available within the runtime itself.
Ah, okay.
So that means that you don't need to add it to the WAR file or jar file of your application. It is already there by selecting the correct dependencies, Maven or Gradle dependencies, by specifying the correct project dependencies. You have MicroStream available at runtime for your application. And of course, it is then also integrated, and that's explained on the next slide a bit, what we have as a minimum on integrations. But each of those runtimes, Helidon and Micronaut, has also some additional things. I did not go over them in detail yet myself, but for instance, what I did saw was that for Helidon, there is also in the health endpoint to see if your process is healthy or not. There you also have something included from MicroStream itself. So it is more than just, in both cases, it's more than just you can use it. There is also some real integration within some other aspects of the runtime. For instance, if I'm correct, with Micronaut, because MicroStream can also be used as a caching solution. For instance, we did not touch that here, but it is also possible as a caching solution. For instance, it implements the JCache specification, where it's not only then a cache, but it stores it also externally, so that you have a hot cache even when your application is just starting. And so MicroStream cache is also possible as implementation for the generic Micronaut caching functionality. So you see there are more integration than the basic things than reading data, writing to the storage. That's what I mean with inclusion. It is included. On the other hand, so those are basically created by the Oracle team and the Micronaut team itself. We help them also, but we are not the only responsible persons for that. On the other hand, we have integrations in the sense that when you add MicroStream to your Spring Boot or Jakarta Microprofile config application or Quarkus application, we have also a integration artifact in the sense that you can do a little bit more than like we did in the templates, than using a singleton to get to the root and to the storage manager itself. The reason why Quarkus is there in italic is because it is not officially released, our integration, and the reason for that is that Quarkus only runs on JDK 11 and higher. So since we are still supporting JDK 8 in the 7 release, 7.0 and 7.1, means that we cannot release the Quarkus integration we have. So it is already in the main branch. So you can build it yourself if you like, and it will be available with MicroStream 8, which the plan is to release it in somewhere in March, April of next year, to switch to 10 entirely, to JDK 11, sorry. But it is there and you can build it yourself, and it is already tested and working. The Spring Boot one and the CDI and microprofile config one are available in the 7.0 and 7.1. I can show a brief example of that so that you can get started with it. What is foreseen in all those integrations, so also when it is included within Helidon itself and Micronaut itself, is that you configure MicroStream, we have seen that you can specify an external file like a property file to read it, but as an integration, you can use the specific config for that framework. For instance, if you're using Spring Boot, then Spring Boot config is used to read the configuration values. So the storage directory, channel count, etc., is then retrieved using the Spring Boot config, which means that you have more than just a configuration file. You have, I guess, if I'm not mistaken, by Spring Boot, you have by default also the YAML files. You can retrieve it even from that Spring Boot config server, so an external process where you configure your application, etc. So for CDI, same there, we use microprofile config because they are closely related at Jakarta and microprofile. So that means that any microprofile config source, including environment including any kind of source, that will be used. Same for Quarkus. There we use small array config, which is an extension of microprofile, so it can do a bit more. And Frank, which is also not only a supporter of MicroStream, but also Micronaut, mentions that I did not put Micronaut config here. So yeah, if you are using Micronaut, then of course, then we are using, or they are using, because we did not write it, so they are using the entire Micronaut config system to retrieve any configuration values to configure your storage manager. So the idea is not that you, in those frameworks, that you not configure MicroStream itself, so that you do not configure the storage manager yourself, but you just specify here configuration values through the options that are provided to you by that runtime. Secondly, with all the integrations, and that's only the integrations that we have created, so Spring Boot, the CDI one and the Quarkus one, you can customize the foundation and the storage manager itself, which means mostly an initializer for initial data, through some beans that implement the interfaces, either embedded storage foundation customizer or storage manager initializer. I will show it. I briefly showed it yesterday. I show it again, so that you, on top of that standard way of configuring it through that configuration properties, you can also do some programmatic additional things, which are sometimes easier to do through code than through config files. What is also available in all of them, so in the 5, our own defined ones and Helidon and Micronaut, is that you can inject the root and you can inject the storage manager. So they are becoming beans, CDI beans, Spring Boot beans, whatever is appropriate for their of the runtime. You can inject those into any kind of bean that is capable of being injected to be. So, of course, not in a POJO, but for instance, in Spring Boot, in any kind of service, for instance, then you can inject the root and the storage manager. And this is an example, and I need to create the examples for other systems, but if you go over all my repositories that I created, then you see that you have a MicroStream Quarkus pattern. So how can you use MicroStream with Quarkus? Then how can you use it with Spring Boot? How can you use it with CDI? I need to create specific ones for Helidon and Micronaut, but they have also documentation on their own how you should use it. For instance, for Micronaut, or did I prepare it already? No. For Micronaut, if you look up for Micronaut, MicroStream integration, Then you get a page from the Micronaut project itself, what you need to do. So, for instance, you need an annotation processor, you need a dependency. So, but they are, see, Micronaut dependencies mainly. So, it's not that it is that we provide them, it is Micronaut itself. So it is included. How you do the configuration, there you can even have multiple storage managers, which is for the moment only possible with the CDI one, not with the other ones, but we are building up that each integration, that each runtime has the same functionality regardless of which runtime it is. So it's not there, we are not there yet, but we are working on that so that you can use everywhere the same functionality. So if you are interested in see how Micronaut works with or what you can do, then you can have a look at this this page. In theory, it is still a snapshot, so it is not a final release. It's a milestone, I think they call it. So it's not final, but so if you have feedback, they are happy to take that feedback and see how it can be improved, of course. For okay, that was the reason why I would jump there for ads for it. So in the Spring Boot patterns, there is here the example where next to a normal Spring Boot dependency and conf and setup of your project, you add the integration for Spring Boot, for instance, for version 7.1. I still have with beta here, but since 2 weeks we are final. So I have to change that. Is it like this? Something like that. I have to change it. And once you have that, then in this case, the storage directory and channel count are possibly, but also other sources, for instance, that application property files can be used for that. Here is that interface that I mentioned, the embedded storage customizer interface, which has one method where you get that embedded storage foundation one, where you can add those handlers, etc. That's something that you can do to customize the foundation. Initializing the storage manager is then so that you can add initial data to your root if they are not there. If this class, for instance, is only in your test branch, I would say, or your test classes, then this can be picked up only during testing, for instance, and then you can create integration testing, etc. So that's one reason why it was created as a bean, so that it is picked up wherever you like, or you can even do a conditional one with Spring Bean, that this is only active on test for references. And then the root object, you need to annotate the root object that it is a storage. That's an annotation from the integration that we have created. So indicate that this is your root object that is used for storage, and then this one will automatically be linked to the storage manager, and then you can inject that into any kind of Spring Bean, in this case Spring Bean like a book repository, where you then, instead of going to the database, write your access here within that repository based on that root object. So all those works more or less the same. These integrations we have written ourselves, so they are even more uniform than the rest. But yeah, as I said, we are working on it to have the same functionality, but do know that if you're using one of these 5 systems, that it is probably easier to develop when you're using those integrations than just do it like we did in in the templates. But as I mentioned also yesterday, the idea of those templates was to get you up and running with a product that provides you endpoints quickly without the need to go through all that integration and explain integration. And yeah, some people are familiar with Spring Boot, others with Jakarta, and others with Quarkus or with Micronaut. So that's more difficult to handle, of course, if everyone is using a different runtime. But for your project, of course, choose the one which you're familiar with and what you use in your company. Is there anything else? Because yesterday there was a question, I forgot who it was, about integrations, who asked a bit about integration. So is this good enough to get you started, or sorry, I did not write down the name, just that I had to do something about integrations today. So but I forgot to write the name who asked for it. So any questions around these integrations other than the really specific one, how to use one of them? Then I should say, look at the documentation. There is always some documentation available. Okay. Frank, yeah, I know you prefer the Micronaut integration, but it's a good one. So no problem with that. Yeah, also here a few links. So you have already the PDF in that GitHub repo. I will update it to the latest version, as I said, tomorrow. But that's that starting point, for instance, that page that I showed you for Micronaut, MicroStream there is also linked here. And I did not find immediately one extensive documentation for Helidon, but if needed, we can create some more material which will be released the next months or so. And the link to the starter code is yet again, but that also depends if you how you're working. Some people like to work more in the low code way, where you generate a lot through generators and the definitions, which might be good. Other people prefer to code itself and have specific optimizations or specific methods for all things, which those low code generators not always do what you like to do, but yeah, have a look at that. There is someone who created a low code generator which uses Micronaut and MicroStream. There was a question this morning about AWS Lambda serverless, if it's possible, any specific things. As mentioned, yes, it is possible. There are a few things that you need to remind and to keep in mind. Yeah, well, I guess always, if you are using those serverless, then you should always go to the cloud storage way of storing, and as mentioned, as close as possible to your process to avoid latency, etc. In that sense, there is that the good news that with the 7.1 release 2 weeks ago, we open sourced all those cloud storage connectors. In 7.0 and before that, these AWS S3 or Google Storage, Google Cloud, not sure the exact name, and The Azure storage were not available in the open source version. It was only for paid customers. But now we have open sourced them all because we see that there is more and more demand for it, and it makes sense that we also release those in the open source version. So as of 7.1, you have those AWS S3 storage connector available. And there was the question if where is the documentation or how can you use it? So I come to that in a moment. One other thing that I would say is that I put it between brackets, but in general, try to make excessive use of lazies, as it's better to overuse lazy when you are doing serverless than not. Just because lazy means that it's not loading the real data, so your memory requirements are lower for your Lambda function. So you only load what is really minimum, required as a minimum, and then you can do a lazy loading based on your request, and of course make sure that you clear them up aggressively, that you explicitly call .clear so that you don't assume that you will need it again, because then it can be cleaned up properly. I come in a moment to your question, Frank. As and as that needs to be capital, of course. I just quickly did it during lunch break. This slide. There is a talk around by Adam Bean, which talks about serverless. Why he thinks that it is the best way forward, and it's but again, that I guess also depends on your type of project, but why he sees that serverless and those lambdas are really good things that as an evolution, and how MicroStream and in general these kind of storages are ideal to work in that serverless environment. So there is a talk around that. I think it's an hour long. It's you can find the link from here, but it is in the if you go to the MicroStream website, you have the when you signed in, so you have the area. So if you signed in, then you have the customer area, but anyone can sign in. There you find several talks. One of them is by Adam Bean, so it's not available on our YouTube channel. But the JCon talks last week, there was at minimum one where we showed an example of, and possibly two. One of the demos was with AWS Lambda functions, and those talks are not yet available, but JCon will make them available. So I would say just keep an eye on the announcements and the channel and the YouTube channel, because at some point they said that it would be within 2 months or something. So it can take a time, but it should be arriving there so that you can see it in action and get more info how you can use MicroStream with serverless.
Thank you, Rudy, much appreciated.
More I could not gather together in those few hours. Question was then, if I use two storage managers and I want to store a copy of the object graph in the other storage, is it better to make a deep copy of the graph? If that's probably probably the safest way, because there was a similar question earlier today where we would store the same object graph to storage managers, and so here also you can have some part of the object graph which is shared between the two. The only problem that arises is that when you're loading the storage manager, because then if you're loading the second one, it can and will override some of a subgraph of your first one, which can be really annoying and really difficult to find out, because you have no idea why, and maybe you don't expect any different values in the two storage managers. So yes, ideally, you should keep to try the object graphs completely separated if you are using two storage managers. Regarding a deep copy, MicroStream has a deep copy functionality for object graphs. I thought the docs were open, but not. So docs MicroStream 1, we have a deep copy. So you can instantiate an object copier, and if you make a copy then of an object, but it can customer, but that can be an entire object graph, then you actually get a deep copy of that object graph. Behind the scenes, what it does is it makes use of the MicroStream serializer. So it takes this object, the parameter, it converts it to a binary format, and then again that binary format to an object again, which then results in your copy, which is then actually a really deep copy, so a completely new version, which is most of the time, especially when you have a larger object graph, much easier than creating a deep copy yourself. So yes, that is probably the best way to avoid all kind of strange, messy things when you have overlapping object graph, that you completely have separated object graphs if you are using two or more storage managers. Yeah, there are a lot of hidden gems within MicroStream that can be useful at some points. A few words around best practices. I have split them up on two pages. There was two slides. One is called development. One is called production. One is about the data model, as we saw yesterday. Review your model carefully so that you can optimally access all your collections. As I mentioned, do we need to access addresses, and are they only available through a long chain, or those kind of things? Add additional lists, for instance, to your root object. It is a bit of overhead to keep them in sync, of course, but it will help you greatly by to access your data. Also, with reviewing, I mean, also see if you need indexing and those map structures carefully with large collections. That's in general JVM, when split them up, include lazy where needed, especially for those large ones, also for those binary ones. What also is important is a proper concurrent access strategy. That's something for the advanced training, but for instance, in the case we have there, we have multiple endpoints. I'm going to open an example. The example is always easier to, but code tells more than anything else. No, at least for developers. For instance, yeah, it's all of course only by update. So suppose that I have only delete and add. That does not matter. We have two endpoints, a add car and a delete. And at a certain moment, we store all the cars because here we have added one, and here we store the cars because we have removed an item. These both store operations work on the same instance. So because it comes from the root, here it is also coming from the root, but it's you see it's coming from the same object. So that means that two different threads are you making use of the same instance. Moreover, MicroStream is looping over that list to find out what is changed and what not changed. So you see, if this store is going over that list through an iterator, and that's the problem, and on the same list you do a remove, you have a concurrent modification exception. So one of the things which are important here, because you're working with a shared data structure, your database, in a multi-threaded environment, your application. You have the same problem when you're doing database, but there the database is solving that problem for you, as we mentioned, mainly by serializing the access through logs and those kind of things. But you have the same problem when you're writing your own code. So a single shared resource, your object graph by multiple threads. So you need a proper concurrency access strategy. That's one of the things that you need to be aware that this code works fine until I write some stress tester, which concurrently calls both endpoints at car and at delete, and at some point it will blow up due to that concurrent modification exception. Does it happen at runtime? Probably not every day, but it will happen at some day, and then, yeah, you know how those things are, things that are happening only once in a lifetime. Then of course that's difficult to find out what's the reason, but remember concurrency because you have a shared structure through different threads. That's how you can handle that, even with the standard JVM. The JVM has some things there for that, read-write concurrency. So how you can use it, that's part of the advanced course. Already mentioned in a question a few times also what happens when there are exceptions, how do you roll back, etc. So also prepare for that one during development, make a good design out of it and implement it rigorously. And again, some hints are and some examples are given in the advanced course. During development, we don't see any reason why you should write specific legacy type mapping handlers yourself, because yeah, it's development. Your data should be not that important in the sense that you can just drop it and recreate your entire database. So it's better purely for development when you're building up your application to just throw away everything and create the correct structure with the correct data and start using that one instead of creating a legacy type mapping. Of course, once you are in production, then you cannot throw away the database, and then you need to write them and you need to test them out, of course. But during development pure, we don't see a real need to write those things, because there is, of course, the automatic one, but the manual one or the more complex ones, if you do really complex restructurations, code restructurations, that that is a bit more difficult than just the pure automatic one. Same reason as the previous one. During development, we don't see any reason to have a backup. So it takes a bit of extra time, not that much, but a bit, and it also takes size on your disk in the best option, or I would definitely not store something on S3 during development, so don't activate any backup. And that's related to the other ones. Use some initial data through mockups, load test data. As mentioned yesterday, also for a question, if you only have reading data, then you don't need even MicroStream for that, only if you want to test saving, if the saving is properly implemented. So try to use mocking, test data, whatever, as much as possible. For production, you should evaluate if you need to update the channel counts. For developments, probably not, because you are using with test data and not with large data sets, or especially not in all cases that you're using large data sets. You can maybe use a larger data set for testing performance or something, but for production, it can be important that you evaluate if you need to update the channel count from 1 to 2, 4, 8, or whatever. That depends, of course, on spikes in your usage, the amount which is optimal. You should check, especially then if you are in higher volume environments, that you might need to tune those housekeeping processes. As I mentioned, you can specify, for instance, for the channel cleanup one, you can specify how much time it gets at that from the channel thread. You can change the interval, etc., to make it more frequently, etc. So if you have those higher volume, higher transaction ones, higher request systems, make sure that you are that you have a look at the housekeeping and that you might change it. Activating backup strategies, if not for not losing your data, it can always be useful for the migration that you might need to do. It's probably safer, and you have no locks, if I'm correctly, on Windows systems, on Windows devices. It's probably safer to copy just the files from the backup directly than from the live production one. So if you have then that backup, you can easily copy the data, and you can use that to see if your new data model, how it works, the automatic migration, do you need a legacy type mapping? Test out probably your program that migrates, sometimes in the more complex ones, that migrates your data structure, your data sources, etc. So therefore, a backup strategy is always good to have in any case, although of course it adds a little overheads on the resources. And yeah, as I mentioned, with that backup data, you can test your data model migrations, because you should do that with production data, because that's also the data which on which it will be used eventually in production. So you might think you have created a good test set, and then maybe you have missed 1 or 2 cases which are there in production but not in test, etc. So if you're using a backup of that production data, and your migration works with that, then I think you can sleep much better than the day before you put that in live version. Any questions, comments around these things?
I have a question. Maybe can you mention some big project that is running on MicroStreams, some big site or something like that? Thank you.
Yes, we have an example. In Germany, you have the Allianz group, so this is an insurance company, and they have migrated, I think it's more than one, even several of their applications to the MicroStream storage. And that's where we also get that number from, that you save a lot on infrastructure cost, because instead of having a large or a rather large environment with I think it was 4 or 6 machines, a cluster, because reading from the database, etc., took time, so it needs to be clustered. They could replace that entire setup with a single machine, because it's so much faster. A second one, which is also live, is on the Frankfurt airport, and that's then an example of another type. So there you have the luggage handling on the plane itself. So they are using handheld scanners, and there they are also using MicroStream because of the offline capabilities. And of course, it's much easier to use MicroStream instead of SQLite, and so they have no connection, so no internet, so no network connection during their work. So they scan everything, and then they go to their station and they do a synchronization of everything. So that's are the two main projects that I may disclose, because some customers they don't want that we disclose what they are doing, but those are the two major ones that I am allowed to mention.
Thank you.
And in case of Allianz, it is a database of, I think, 2 or 3 gigabytes of data in total, of course, with a lot of lazies, but it is, I think, it is 2 or 3 gigabytes of data. Some other loose ends, some loose blocks. There was the question of AWS. So for AWS S3, you need to add an additional dependency, but you also need the S3 SDK clients. I think I have here in the example. Yes. So as a dependency, you need the AWS S3, but you see it's the same on our documentation site. And then you need to SDK from Amazon. And once you have an S3 client, and that can be you can do it with basic credentials, but probably it's better to have, but it's the shared key or external files or whatever. So point is, we need an S3 client which is capable of accessing your resource with the correct credentials and keys, etc. Then we need to indicate that we are using that blob storage file system, the abstract file system, not the disk one, but a blob one, so binary large objects. And then we can, for instance, using this one, but you also have the possibility to use it at the builder and the other one. They are also possible, but with a short way route and the location using that blob file system and the S3 bucket name. This is enough to connect your storage manager with S3. Data is here. This is if you're using external configuration files with the keys. If you are using it within Spring Boot and all those others, you need to prefix it with one.microstream. Whatever. So there you need to prefix it, but this are the values and the supported properties, etc. So these are the ones that you can have a look to get started with Amazon S3.
Hi, Rudy. And you do that for a second time to make an object for your backup.
Yes, also.
So you make two objects, one for your root and one for your backup, and then.
Yep.
Okay.
I see what you mean. Let me open our example from yesterday. Where is the example from yesterday? It's not open, I think, because this is the config from my presentation. Let's open it like doing this. So it is this code. It is the basic training one config. You have then, I think is it possible with builder? No, you need to have this foundation one here, where you can have the disk as the normal one, and then this one will be that blob storage one, etc. So if you like, I can so that you can see it easier. So this needs then to be duplicated. And you need the blob one. I'll copy a few things from this one. Yeah, it's in error because I don't have the correct dependencies here, but then you can have, I'm going to call it S3 file system. And then you can have something like this there. So, and like this, and then you can put it here. So this would then be, if you fix the errors because I have missing dependencies. This would be more or less how you use the standard directory as primary and then the S3 one as a backup one.
Just to be sure, Rudy, the first one is part of your application, which is saving its information over there, and the backup is saving the information in the S3 bucket.
Yes.
Okay.
But that happens more or less at the same time. So every time you store something, it first goes to the primary storage, your main storage, and then if you have defined a backup, it also goes to the backup one.
Okay. Is it a misunderstanding of me that I was thinking that both of them needed an S3 bucket?
No, you can mix and match whatever you like. You can have here also an S3 one. You can have an S3 storage as a primary one also.
But then you have to have a separate S3 account, as you said, for both of them.
Well, at least a separate bucket name. You can use the same. You can use the same client, but you need to have a different bucket name. So you need to store it, yeah, next to each other. But yeah, it's another bucket. I don't know how. And sometimes I compare it with another disk. So you store it on another disk in your S3.
Okay, thank you. Thank you.
But yeah, you can mix and match. You can make this one also an S3 one. So to make it an S3 one, that's even easier than no, because it is a file provider. Okay, I thought it just copied this here, but that's not the correct way. But you can mix and match as long as it is an implementation of that abstract file system. It does not matter. So it can be like this, mixing disk with S3. It can be S3 with S3, whatever you like.
Thank you.
I hope the Strato high drive S3 bucket will be supported, so it's cheaper than AWS. It's the first time that I hear about that Strato high drive, but I make a note of it so that at least it's on our agenda. S3 buckets are already very cheap. So if it's AWS SDK compatible, it should be working already, as long as you provide it with the correct client, which is, yeah, if you say it's compatible, then you provide it also an S3 client. It's probably only different than in the what's called the repository name, or is it the URL name, and etc. So if it's purely compatible, then it should work. If not, then yeah, of course, then probably we need to change and tweak a few things. By the way, you can create those AWS systems yourself. There is an example how you can create such an AWS, an abstract file system, an AFS system yourself. So even if we did not provide them, you can create your own one by implementing an interface. An example that you can find, if I'm correctly, if I'm think it is where it is, GitHub MicroStream. The example is to is with an in-memory. Okay, it's not really useful because it is in the same JVM memory as it is here. So this is an example where it is using that Java in the memory file system of Google to store your data. Of course, it's just an example. It's useless because when your JVM goes down, you've lost your data also. But that's an example of implementing your abstract file system yourself. The same. Most of the time, we get questions about how to access, how to store things in a database. So I can show that and also quickly. That's more covered in detail in the advanced one. For the database, you need the SQL one, abstract file system SQL, and you at minimum need the JDBC driver for the database that you want. And for the configuration, you can do it also programmatically. Here it is an example of configuration file. You need to specify a class which implements a certain interface. It's an interface of MicroStream. And this interface is called whenever MicroStream needs to have a data source, so a connection to your database. Then you get that configuration. And what is that configuration? Well, that's the other values that you specify here. So this password, user, and URL are not mandatory by MicroStream. They are because they are most of the time used like that, and we specify them here. So I can easily use here other names. I can, for instance, use here user name, but then of course, then I need to make sure that I'm reading the value of username. And based on all those properties, as URL, username, and password, I can create my data source specific for my database that I want to use. So that's SQL data source provider is basically the main thing that you need to know on how to connect to a database as storage. Are there any other loose ends that someone wants to discuss?
I was just curious if there is something for encryption of the data store, of the storage.
Yeah, well, that question comes up often, so I think we need to work on that. So no, we don't provide any kind of encryption of the data storage. So that's something that you need to be using from the underlying system. For instance, those cloud storages, they are either encrypted by default or not accessible, or you can do an encryption for some of them, but no, we don't have any kind of encryption available.
Do you think it would be possible to use the AFS, what was the name, provider, or the AFS API to implement my own encryption?
Yes, sure.
Should be, right? Because it's just transparent to the system.
You can extend as an example, for instance, the disk one or the other one, and you can, an additional step can be the encryption. Do know that you need, I'm not saying that you need to be an expert, but that encryption and all those kind of things, there are a lot of corner edges and cases, etc., and that makes that it might be not as secure as you think that it is, that you're intended to be. So yeah, just make sure that you follow all the things according to all the best practices and the books, etc., so that it is properly done and that it cannot be accessed then, because I sometimes have the impression that people, oh, it is encrypted, so no, that should be important, so let's try to hack it. And if it's not encrypted, they say, oh yeah, whatever, it's not encrypted, so it's not important, I don't bother looking into it. You see what I mean? So make sure if you do encrypt it, that it is really safe and that it's really tight in all cases. But it is on our agenda. It is, I think it's even already a issue on our list that we have to look into encryption.
Also, is there some kind of roadmap for future MicroStreams features?
We have, to be honest, we only have a bunch of issues which are not really prioritized for long term. We have more ideas of what will be coming in the next versions, but not long term, let's say 1 or 2 years or whatever. So, or at least I don't have that list for the moment. So I'm not aware of a exact nice roadmap that we are planning. There's a question about my data is now in SQLite and growing. Curious on how to migrate and synchronize. I think, yeah, if you're, and that there was a question for an example, but I don't have an example at hand on how to migrate an existing setup with the database to one with MicroStream. That is, of course, possible. It will be some kind of a challenge in the sense that, first of all, you need to extract the data from whatever database, SQLite in your case, or in any other kind of database or NoSQL or whatever. So you need to extract the data and store it in the MicroStream format. So you need to have some kind of conversion program that reads all the data and then stores them once they are in memory and stores them then to disk or whatever storage you need. But then, of course, you also need to adapt your program because you are no longer using Hibernate or whatever tool to access the data as it was before, but you just need mainly those stream APIs. So I don't say that it is impossible, but it is, of course, a undertaking which takes more than a day. You mentioned there the word synchronization. So if you want to keep it both, is that the idea that you both keep the SQLite data and the MicroStream version so that?
What I do is I have web scrapers working right now. So my data is growing in SQLite. And if I want to have an application using that data, then I have to be connected to that SQLite database, look the difference, and then do my production thing in MicroStream, because that's a lot cheaper than using the data, than using the SQLite database.
And of course, the first step, scraping and putting it into SQLite, is that something that you can change so that it is immediately MicroStream?
No, that was such a lot of work to have it running. I will not change that.
Okay, yeah, it's just a question, you know, because it is perfectly fine if there is a restriction. Yeah, then you need to somehow to identify again no records, and it's. I see it possible. That's not the problem, but yeah, we need a bit more, of course, in detail and analyzing the entire process, see what needs to be changed, what can be done, etc. So it is not yet announced, but in that sense, it makes maybe a good case or not. That's up to you. We are launching some kind of proof of concept program, but that will be then for the MicroStream cloud. So if you have a use case that you think this might be something for MicroStream that I am adapting, creating something new or whatever, then you can participate in that proof of concept program, and then we work with you together to get you started. We work together from point from architecture analyzing to helping the development tips and tricks, coaching to get the things done. So it's not launched yet. I know it will be soon. Is it this week, next week? I'm not 100% sure. Marcus was on earlier, but I don't think he's on now. So I cannot give a fixed date for that proof of concept programs. But if you're interested, if you see it passing on our channels on our website, then maybe you can apply for that, and then we can see if we can help you with that or not.
Oh, would be great, Rudy. I don't think my use case is very strange, is it?
Well, I would say that every use case is unique, because we are everyone is making his a program for his unique use case. So you are unique and strange in that sense, but yeah, is it extremely different from other things? Probably not. No.
Thank you, Rudy. I will watch your site. Thank you.
Yeah. Which question? Which web framework or microservice framework adds the least overhead to MicroStream in terms of performance response times from your point of view? That's a difficult question, because I said they all just basically all read those configuration files, create the storage manager, create a bean for it, and that's about it. Is there will be there a difference between frameworks? Probably. Is that noticeable? I don't think so. So what's although I'm a Jakarta EE guy, for those who know me, I always say that probably it is more important that you choose a framework that you are already familiar with, than instead of trying to switch to something which might be shining, but before you know all the internals and know the specific things, that you lose a lot of time, a lot of effort to learn that, and maybe with the framework that you already know, the job was already done. Unless there is, of course, a specific requirement which is not cannot be fulfilled in one framework, which is available in another. But so the question is there one which dramatic less overhead than the other? I don't think so. We can still answer questions, but there is the next advanced training is on for the European zone. It's October 13, so it's in 2 weeks. It's a 1 day, also between 9 and 4. And you can find it on the javapro.io/training URL. You find this overview where you can click on details then, and then you can register yourself. And if you're using the booking code MicroStream-2022, then it's for free for the first number of people, and that's more than those what I met. We are with 10 participants here now today, so it's more than 10. So if you go to that site, you are guaranteed that that you can get in training for free. What's in there? This is officially advertised, but you see also yesterday and today we slightly deviated from it. So we are going a bit more in detail around advanced configuration of those storage ones, although we did already a lot of them. Also a bit, yeah, I will post a link in the chat in a moment. We also go a bit deeper in the housekeeping and these tutorial channels, how they work internally. Also going a bit deeper in eager and lazy loading. So there are a few more advanced stuff that we handle. And then, as mentioned, proper transaction rollback, although real transactions, they don't exist in this setup, but more go back on exception handling, rollbacks, etc. Integrations with things like Apache Lucene that I was mentioning yesterday, also of if you do a search just by starts with, is maybe more performant to use things like Apache Lucene. So how can you integrate those things? But it's just an example. You can basically integrate it with any system that is that works within Java. That concurrency handling, which I said was important. And then we go also deeper into the type handler, the custom type handler, the legacy type handler, etc. So that's what advertised in the agenda, but yeah, it might slightly change. Probably integrations will be added to that, so more deeply, that you are really not what I told you, but really go into the details of it. And then the link is this one, and I put it in the chats for everyone. So you can filter on MicroStream because we have other trainings planned. And then you can hear, for instance, for in 2 weeks, the advanced one. This was that course overview. And then you can register. And then you should use that discount code MicroStream 2022. And then it's for free. Don't forget to select the date and time, so in 2 weeks.